All right, the paper today we are discussing is the model paper from University of Moto Engineering faculty. Every year they release this model paper, and this is from the year 2020. Right. Physical quantities having the unit same as the ratio between electric flux density and magnetic flux density EOBs. All right, so we need to find out the dimensions of EOB or units of EOB. Now, when I say EOB, what comes to my mind first of all is first force, electrostatic force is equal to QE. That is the equation which connects the electrostatic force and electric field intensity. And F equals BIL. F equals BIL. That is the magnetic force, correct? So when you combine these two, both are equal to force. Therefore, we can say dimensions of QE should be equal to dimensions of BIL. These two, I think, are the most convenient equations. Up to you. You might have chosen some other equations, but it's okay. Anything, right? And then I need a B over B. Sorry, E over B. Therefore, E over B, dimensions of E over B, it's going to be equal to, on the right side, I and L are there, and on the left, and from the left side, Q will be coming down like this. Right, I is current, the dimension is I, length is L, dimension is L, and Q is electric charge, dimension IT. Therefore, I and I will get cancelled out. Finally, you will be getting L over T, that is LT minus 1. LT minus 1 is the dimension of velocity or speed. I think we have velocity as the answer. Therefore, the answer is first one. Right. Question number 2, it is matter and radiation. If you haven't studied matter and radiation, you don't have to worry about it. If you have studied about it, it's the Wien's displacement law. That's the equation we should be using. What is the Wien's displacement law, people? People have learned Wien's displacement law is lambda, wavelength corresponding to the maximum intensity into temperature, it's equal to a constant. So we normally say it's equal to constant. So we can say lambda 1 T1 equals lambda 2 T2. So what is the question? The graphs indicating the distribution of intensity of a black body when the absorption temperature of its surface is 4T and 5T are shown. If lambda 1 is 10 micrometer, so you can see lambda 1 corresponds to 4T and lambda 2 corresponds to 5T. Therefore, lambda 1 is 10. T1, careful, it is 40, the maroon color one I underline. Lambda 2 we have to find out. Lambda 2 we have to find out. Into T2 is 5T. Simple as that. If you know the equation, if you know the content, it's very easy, very straightforward question. And then the final answer, 8 micrometer, 8 micrometer. If you can simplify this to people, 8 micrometer. T and T will get cancelled out. You'll be getting 40 over 5. That is lambda 2. 40 over 5, and the answer is 8 micrometer because I substituted for lambda in micrometers initially. Second answer. Third question, third question. Which structure correctly shows the change in structure of quarks of a nucleon in nucleus and lepton emission during beta minus emission of a radioactive element? Now, beta minus emission. This, I think anyone who has done, who even has a little bit of chemistry knowledge can do it. Beta minus emission means one of the main examples we choose is the emission from carbon-14 isotope. From carbon-14 isotope, who is emitted, when beta minus is emitted, you will be getting nitrogen atom, nitrogen nucleus actually. When beta minus, you know how this works, right? When you add the upper parts, they should be equal to this. When you add the bottom ones, they should be equal to this. If you see in carbon, you have 6 protons and 8 neutrons. In nitrogen, you have 7 protons and 7 neutrons. So what has happened during a beta emission, people? 1 neutron has become a proton while beta minus is emitted. Okay, why? 8 neutron has become 7 neutron. 6 proton has become 7 proton. So 1 proton has increased, 1 neutron has decreased. Therefore, the ultimate reaction which is taking place is 1 neutron. Neutron, we know it is 0, 1. It is becoming 1 proton, they are plus 1, 1 with the emission of beta, and there will be another particle called the neutrino. So what is the answer? neutron becoming proton. There's only one. Okay, there are two answers. Neutron becoming proton. What is neutron? Last week also we studied neutron. I explained you how to remember the quarks in neutron and proton. Nud. Food. So UUD means proton. UDD means neutron. Which one is the proper answer? Yeah. Here no change. See, no change here. No change. No change here. Down. Okay, up, down. We have to find that. Wait. Who is becoming who? A neutron is becoming a proton. So neutron is becoming. This is wrong, no people. This is wrong. This is not proton. This is the correct one for proton. Neutron has to become proton, right? First is the answer. No? Third one. First is the answer. First is the answer. This is for again for people who have done quantum physics. We don't have advanced quantum physics in our syllabus. Very quite basic. Neutron has to become proton. There are only two answers, two such answers. Wrong, wrong, wrong. Why is this wrong? Because this part is wrong. Proton is UUD, up, up, down. Here it says UDD. Done. So first 3, 1, 2, and 1. Moving on, fourth question. The wave in a stretched rope has frequency f, wavelength lambda. When tension of the rope is changed, when tension of the rope is changed, the frequency and the wavelength of the wave are 3f and 2 lambda respectively. What is the ratio between the initial and final tensions of the rope? Right. Okay. Fourth one. Right. We know V is equal to F lambda. That's the initial one. V is equal. Okay, I'll start with V equal to F lambda. So V1 is equal to F lambda, and we know that is equal to square root of T over M. First equation. For the first case, right? When it is F and lambda, I'll underline them in maroon color. And then the next case, this 3f and 2 lambda. Therefore, the new speed, that is 2f into 3f into 2 lambda. 3f into 2 lambda, that is 6f lambda, and that will be equal to square root of forgot the tensions T1, and now the new tension is T2 over M. M is constant because we did not change the rope. Mass per unit length of rope will not change if you don't change the rope. So what should you do? You divide the second one by first one. When you divide the second one by first one, you will be getting on the left side 6, and on the right side square root of T2 over T1. The question is, what is the ratio between the initial and final tensions? So that is 36 is equal to T2 over T1 when you square either side. But the question is about initial and final. So T1 over T2 is equal to 1 over 36. T1 over T2 is equal to 1 over 36. And simple again, first answer. Okay, should not be wasting a lot of time for this. Very easy. Fifth one. What is the approximate work done by a cell in order to move 6 into 10 to the power 28 into 10 to the power 18 electrons across 20 volt potential difference? What is the equation for work done, people? To go to question number 5. Equation for work done electric field is Q delta V. Work done charge into potential difference. The work done is what we are supposed to find out. Now, what is a charge? Charge will be number of electrons multiplied by the charge of one electron. 1.6 into 10 to the power minus 9. Don't put minus because we are asking for the magnitude. Into potential difference is 20. Right. When you multiply these things, what do you get, people? 32. 20. Was 20 the answer? 20, I think. Yeah, 20, right? Yeah, easy. 20 joules. Because I have 32 and 6.28. When you multiply 32 by like 6.28, it's roughly close to 200. That's how I figured out answer. Okay. Right. Next one. During a thermodynamic process, 2 mole of gas releases 30 joule of heat energy. Okay, releases 30 joule of heat energy means delta Q is equal to minus 30. Okay. If not releases 30 joule of heat energy, so it's delta Q equal to minus 30 joules, and 20 joule of work done on the gas. What is the meaning of 20 joule work done on the gas? That is delta W equal to minus 22. If its internal energy is 20 joules, what is the final internal energy? Nice. Now they have given you the initial internal energy level. I mean, they have given you internal energy, initial internal energy. I'll take it as a U1 equal to 20 joules. U1 equal to 20 joules. Right. Now what can we do? Let's go with the first law of thermodynamics. You know, it's delta Q equal to delta U plus delta W. Delta Q is minus 30. Delta U, what is delta U? Delta U will be final minus initial. I'll put UF minus UI, final minus initial, plus or else plus minus 22. Okay, you have to be really careful with the numbers here, the signs. And so I have minus 30, this 22 goes the other side, I have minus 12 here. And here I have UF final. UF is the final one, minus 8 here, no, we got minus 8. Minus 8 here. UF minus UI, it's 20. UI is 20. Therefore, 20 minus 8 is UF. That is the final internal energy. Final answer, UF is equal to 12 joules. For fourth one. I hope that's clear, everyone. Huh? Just first of all, you have to extract the information carefully. Energy released, so minus 30. Q, delta Q is minus 30. Work is done on the gas means minus. Work done by the gas means plus. So I'm putting this equation, and delta U, always remember, delta U is equal to final internal energy minus initial internal energy. That's the equation, and we'll get 12. Right. We're on with 6. Go to the 7th one now. Right. 7th question. Right. The sound intensity level at a certain distance from a sound source is 8 decibel. If the power of the sound source is increased to 10 times, the sound intensity level at the same point is. Sound intensity level at the same point means, you know, simple R, that is constant. Simple R is constant. So we all know intensity, that is equal to power over area, and area means your power over pi r square, 4 pi r square actually, 4 pi r square, no, from a point source. Since R is a constant, it's the same at the same point means from the source R is constant. Therefore, you can say from the when you consider the information here, I is proportional to power. I is proportional to power. Right. Sound source is increased by 10 times. Now I'll start like this, people. I1 is proportional to P. I2 is proportional to 10P. Do you understand? Because it was increased by 10 times. Increased by 10 times. Therefore, you will be getting I2 over I1, that is equal to 10. I2 over I1 is 10. By initial, I have taken the initial power as P. The power was increased by 10 times. When you increase the power by 10 times, the intensity at the same level is going to be 10P. It is proportional to 10P. Therefore, this. And they have given us beta. Beta 1 actually. Beta 1. Beta 1 is only given to us. Beta 1 is 8 decibel. Beta 1 is 8 decibel. Beta 2 is what we are supposed to find out. So you have all the information here. What should you do? You have to apply this equation. Beta 2 minus beta 1 equal to 10 log I2 over I1. You have to remember this equation. When you compare the sound intensity levels between two different points. Beta 2, that is beta 2, we have to find it. Beta 1 is 8, 10 log of, what is I2 over I1 people? 10. And what is log 10? 10 into 1, that is 10. So beta 2 is equal to 18 decibels. 18 decibels. You can't make mistakes in these people. There are almost every year there is an MCQ. Every year there is an MCQ. So you must have practiced these questions so many times. You can't afford to make mistakes in this. Doppler's effect, sound intensity level. These are very commonly asked questions. Almost every year. Question number 8. A steel plate contains a circular hole. The temperature of the plate is increased to 100 degrees Celsius. At that time, if the fractional increase of area of the hole is 2.4 into 10 to the minus 3, what is the coefficient of linear expansion of that substance by which the plate is made of? Guys, fractional increase in the area. What is that? That is delta A over A, and that is given by 2.4 into 10 to the power minus 3. Okay, right. How do you handle this? You can say delta A, we know it's equal to A naught beta delta theta. That is the equation. So delta A over A naught is equal to beta delta theta, and we all know beta is equal to 2 alpha delta theta. Delta A over A naught is 2.4 into 10 to the power minus 3 equal to 2 alpha into delta theta is 100. Delta theta is 100. So I'm going to get alpha is equal to 1.2 into 10 to the power minus 5. Minus 5. The unit is missing now. Per degree Celsius. Per degree Celsius. I think in every answer the unit is wrong. Do you agree? Unit is wrong. Should be per degree Celsius. Change it. The second answer. I hope everything is okay. Right. 9th one. In the given circuit, or in the given electrical circuit rather, the current through the resistance R1 and R2 in between the current supply across XY ends are 3 ampere and 2 ampere respectively. What is the resultant resistance of the unknown resistance connected across AB? They have given R5, R8, R7, R6. Oh, no problem. So what you need to do is you have to forget about all those things. Instead of all those things, what you need to do is you have to just consider it as one single resistor. You have to consider it as one single resistor. So I need to find out the resistance between A and B. In other words, let's say if you draw it again, which I don't like doing it, but never mind. You have a resistor here, and instead of all these things, you just put RAB here. That's it. RAB, and this is 3 ohm. This is 4 ohm. This is 6 ohm. This is 3 ohm, and this is 8 ohm. Whenever we come across a situation like this, what should you try to figure out? What should you try to see? If we can ignore this one, R2, that means if this is a Wheatstone bridge, then the life becomes very easy. The ratio 4 over 6 is equal to RAB over 3. Most of the times, 99% of the times, that's the case. But we have to be absolutely sure whether we can ignore this or not. Right. Let's see whether we can ignore it or not. I'll start with this point. It's at X connected to X. So I'll take the potential at that point as Vx. They have given you current. They have given you resistance. So what is the potential difference across these people? V equal IR. V equal IR. I is 3 ampere into 4, 12 volt. 12 volt. Potential drop across that is 12 volt. That means what is the potential at A? Potential at A is going to be Vx minus 12. And how about this one? Potential drop across this one? Again, you can use V equal IR. I is 2, R is 6. Surprisingly, that is also 12 volt. That is also 12 volt. That means at this point, potential is 12. Vx minus 12. Vx minus 12. Therefore, will this work? This is not going to work. Because at this point and at this point, potential is same. Potential is same. So what is this, people? Wheatstone bridge. This is a Wheatstone bridge. Wheatstone bridge. All right. If that is a Wheatstone bridge, things become very, very convenient to us. What should I do now? If you take this circuit, I know 4 over 6 is equal to RAB over 3. RAB over 3. So this 2 can be cancelled. This is 1 and this is 2. 2 is the answer for RAB. RAB is equal to 4 divided by 2. That is 2 ohm. Therefore, we can settle to first answer. Yeah. Good. 10th one. The ball is thrown towards the floor from height h. When it rebounds after colliding with the floor, it loses half of its kinetic energy. Then it reaches a maximum height of 2h before it reaches the floor again. What is the initial speed of the ball? Okay, right, interesting. Ball is thrown towards the floor from height h. When it rebounds after colliding with the floor, it loses half of its kinetic energy. Then it reaches a maximum height of 2h before it reaches the floor again. What is the initial speed of the ball? Now you can approach this question in 2 different methods. Right, let's see. First of all, this is the flow. You're dropping the. What is the question? Okay. Now this is something very important. The ball is not dropped, people. It is thrown. You have to understand that very clearly. Height is h, and it is thrown vertically downwards at an initial speed of u. It has an initial speed, so it has an initial kinetic energy and the potential energy. And then it reaches the ground. When it reaches the ground, it will have a speed of some speed v, and then it's bouncing back. When it bounces back, it has lost half of its kinetic energy. It has lost half of its kinetic energy, and it reaches a maximum height of 2h. Final velocity becomes 0. Now you shouldn't be asking, sir, how can it go to 2h after starting from h? It is not possible if you drop the ball. It is possible if you had thrown the ball. Correct? It's possible if you have thrown the ball. Okay. Now when it reaches the ground, it will be at velocity v1. When it bounces off with velocity is v2, and then it reaches it will be 0. Now you can apply the energy principles and get the answer quickly. So how do you do that? First of all, this is situation 1, and this is situation 2, and this is situation 3. You know what? 1 is ball going down. 2 is ball changing its kinetic energy by changing its kinetic energy, direction changing, and the third part is from here it goes up. So if you write the equation for the first part, what is it? You can say half mu squared plus mgh equal to half mv1 square. That is the first part, correct? For the second part, what can you write, people? Half mv2 square is in fact half of mv1 square. Sorry, half mv1 square. Half of half mv1 square. Hope you can agree with me. And then tell me the third equation. Third equation is here kinetic energy at this point, half mv2 square. That is equal to what? mg into 2h. mg into 2h. All right. These are the 3 equations. Right. Now I need to find the initial speed. What is the initial speed of the ball? When they say initial speed, that is initial speed of the ball. That is u. Okay. I have 3 equations to connect everything. I'll connect them one by one. These are the 3 equations you can write to people. First equation, from here to here, energy. Second equation, the transformation of kinetic energy. Third equation, again, energy. Initial kinetic energy, final potential energy. These are the 3 equations. Now, from the third equation, look at the third equation. I'll use the third equation and substitute that in the second equation. So I'll write it here. Now the second equation will give you, in second equation, instead of half mv square, if not, okay, we'll write like this, then it will make more sense. Let's combine second and third. If you combine second and third, you will be getting 2 mgh equal to half into half mv1 square, right? Therefore, half mv1 square is equal to 4 mgh. 4 mgh. And now we go back to first equation. We go to first equation. I have half mu squared. I have half mu squared plus mgh equal to, instead of half mv1 squared, I can substitute 4 mgh. Right, simple. And then all the m's will get cancelled out. And if you take, I have 4gh, here gh, u squared by 2 becomes 3gh, u squared is becoming 6gh, root of 6gh. U is root of 6gh. Is that okay? U is root of 6gh, and the answer must be fifth one. Right. Raise of hands if whether you understood this explanation or not, please quickly. Don't write way too many equations and make it a mess. Just keep it simple. Okay. Right. So if you are written way too much to do the questions, you just have I have in one screen, I have explained 1, 2, 3, 4 questions. Okay, right. So this is one method of doing that. Someone wants me to explain it again. Okay, right. I'll explain it in another method also. 10th question. Wait a minute. Take the 10th question. I'll try to explain another method. Now you can do this question backwards as well, people. You can do the question backward as well. You start here at an initial speed of u and at a height of h. All right. The ball reaches the ground and then the ball bounces back. The ball bounces back and then reaches a height of 2h. Now the new height is 2h. And here the final velocity is 0. And we'll take this as a 0 potential level. Okay. And at this point, what is the potential energy? M into G into 2h. So that is 2 mgh. That is the potential energy. And at this point, people, there is no kinetic energy. Kinetic energy is 0 because velocity is 0. Tell me, what is the energy we have here? What is the energy we have here? We have kinetic energy here when the object is bouncing back. When the object is bouncing back, and here the object is hitting the ground. Right. Tell me now, what is the kinetic energy here? Whatever the potential energy you have here will be equal to the kinetic energy here. That is 2 mgh, and the potential energy here is 0. Hope you guys understood it. Here you have 2 mgh potential energy, and whatever the kinetic energy we have here will be converted to that because we are not considering air resistance. Now tell me, what is the kinetic energy here? What will be the kinetic energy here? Hurry up. Can someone tell me? What will be the kinetic energy here? What will be the kinetic energy here, people? Where you tell me? Where? What will be the kinetic energy here? In the question it said the kinetic energy reduced by half. The kinetic energy reduced by half. See, it loses half of its kinetic energy. It loses its half of its kinetic energy. So if it bounces back, if it has 2 mgh kinetic energy, when it hits the ground, it should have 4 mgh kinetic energy. 4 mgh. Out of 4, half is lost. So if the returning one is 2, the initial one should be double of that. 4 mgh. 4 mgh. Okay. Right. And now at this point, tell me, at this point, what are the energies we have? We have kinetic energy is equal to half mu square, and we have potential energy also. How much is that? Mgh. I'll take this as 0.1. I'll take this as 0.2. Okay. So we know kinetic energy at 0.1 plus gravitational potential energy at 0.1 should be equal to kinetic energy at 0.2. Kinetic energy at 0.1 is half mu square. Potential energy at 0.1 is mgh, and kinetic energy at 0.2 when it hits the ground is 4 mgh. So m gets cancelled out. Therefore, again, you will get the same thing. u squared by 2 is equal to 3gh, u squared is equal to 6gh, and u is going to be equal to square root of 6gh. This is another way of doing it. From the reverse, you can go from the reverse. Okay, so don't forget, whatever the potential energy you have here, the kinetic energy you have here will be equal to the potential energy here. So I first found the potential energy at this point, 2 mgh. Same kinetic energy I will have at the ground here. But when the object hits the ground and bounces back, it has lost half of its kinetic energy. So this is just the half of the previous kinetic energy. So if this is 2 mgh, the kinetic energy before it changed direction should have been 4 mgh. So whatever the kinetic energy you have here should be equal to the potential energy and kinetic energy at the initial point. Now the main mistake you guys might have made is, but so how can this raise to 2? Because Malaysia, it had an initial velocity here. It had an initial velocity. Imagine the 2 mgh, that value is 20 joules. Here the potential energy is 10 joules, but because I'm giving it a velocity, I'm giving another maybe 35 joules of kinetic energy to that. Okay, that's the difference. This question, it's a very good question. I really love this one. Not a conventional question we get. Normally we drop objects. Here we have thrown objects, so it can rise to higher. A 1 enclosed resonance tube P1 is vibrating in its first overtone. 1 enclosed resonant tube, first overtone, maroon color. Another resonance tube P2 open at both ends. Tube P2 open at both ends is vibrating in its third overtone. Both these frequencies resonate with a particular tuning fork. So frequencies are equal. That's the meaning. Frequencies are equal. What is the ratio between the lengths of the tubes P1 and P2? Now they should be bread and butter. 1 enclosed tube, first overtone. So you will be drawing a rough diagram like this. No? Length is L1 and same frequency. So they should have same wavelength as well. So speed will be same. No? This is the first overtone. Same frequency, same wavelength. Both will have same frequency and wavelength because they have the same speed. What is the equation here? L1 is equal to 3 lambda by 4. And for the next tube, both an open tube, third overtone means you should have should have 2 loops, correct? You have 2 loops. This is the third overtone. And the length of this will take it as L2 and F and lambda same. And what's the relationship between lambda and L2 this time? Sorry, L2, it's actually equal to 3 lambda by 2. So the important thing you have to understand is both will have the same wavelength because they have the same frequency. They are resonating with the same frequency and they are subjected to the same speed of sound in air. So what shall we do? That's it. I mean, what can we do next? We can make lambda subject and finish it off. Lambda here will be equal to 4L1 by 3. Here lambda is equal to 2L2 by 3. Therefore, you can say 4L1 by 3 is equal to 2L2 by 3. Oh, easy. 3 and 3 gets cancelled out. Here are 2. What are we supposed to find out? P1 over P2, length of P1 over P2. That is L1 over L2 equals to half. Third answer, people. Straightforward. Sorry. I think I made a mistake here. No? Sorry. Yeah. Thank you. Right. Okay. So I was wondering, oh, here I made a mistake. What is the mistake? This is not the third overtone. This is the second overtone I have drawn. Right. Sorry. So I should draw 1, 2, 3, 4. 3 loops must be there, people. 3 loops must be there. 3 loops. Beg your pardon, 3 loops. This is L2 and L2 this time, same f and lambda. Lambda is equal to 4L1 by 3 and L2 this time is equal to 2 lambda. Therefore, lambda is equal to L2 by 2. So 4L1 by 3 equals L2 by 2. Hence, L1 over L2 is equal to 3 over 8. Sorry, beg your pardon, 3 over 8. Second is the answer. Not the third one. Second is the answer. Right. 12th one. Two identical masses are connected by an elastic string similar to a spring of force constant K and unstretched length L. Those two masses are hung from the ends of a string which passes over a frictionless pulley. What is the total length of the string at equilibrium? Now, equilibrium, at equilibrium. Equilibrium means the system is not moving. The system won't be moving because there will be mg here. Here also there is mg. So the tensions will be equal to mg. Tensions will be equal to mg. I think it said it's a light string, right? Now, what will be the length of the string, people? How do you find the length of the string? Now, you need to understand one thing. Imagine there is a string like this, okay? There's a string like this. Initial length of L. If I give a force of mg on either side, that is what's happening here. Mg is given on either side, people. Mg is given on either side. How should I write the equation? Now, the force given is mg from either side. Mg, mg. Think of it like that, Philip. What should I use? How should I use the equation? Now, definitely we'll have to go for Hooke's law. So F equals Kx, where x is the extension. For F, what should I put? For F, what should I put? For F, what should I put? Force. Should I put 2mg or mg? What should I put? You should put mg. You should put mg. Not 2mg. You have to put mg equal to kx. So x is equal to mg over k. X is equal to mg over k. That is the total extension. X is the total extension in the string. X is total extension, okay? Right. Total extension. So if x is the total extension, what is the total length? Now, total length is going to be equal to initial length plus x, that is L plus mg over k. Therefore, the answer is second one. Right. Now, I know some of you have an issue there. How did I take mg here instead of f? How did I take mg here? Right. Okay, fine. Now, this is how you have to approach that, people. Imagine you have a string or spring, whatever it is, and it has a spring constant of k. If you're going to apply a force from either side, like this, separate it into half pieces. Separate it into half pieces. And think, will you? Mg. Yeah. Okay. Now separate that in half. That this way, I think you will be able to understand it conveniently. Think of this half experiencing the force mg. Sorry. Imagine this half is experiencing force mg, and the other half, left side half, is also experiencing force mg. Right now, you can find out this small extension. I will take it as x naught, and this small extension x naught. We have to find the total extension, people. Total extension. What I have found here is total extension x. Now, how will you find x naught and x naught separately if you want to find? Now, if you're going to consider half of the spring, half length, no. So for the total length, if it is k, for half length, it's going to be 2k. 2k and here 2k. Hope you can remember this. When you reduce the length of the spring by half, spring constant will become double. Okay. Or if you reduce the length of the spring by 3 times, the spring constant will become 3 times. Now for this end, if you apply that Hooke's law equation, okay, F equals Kx separately, then F is equal to mg. For K, you will put 2K x naught. Therefore, so what is x naught? Mg over 2K. Mg over 2K. So total extension. What is the total extension, people? Total extension is equal to 2x naught. It is getting extended on the left side as well as right side. 2x naught is 2 into mg over 2k, that is mg over k. That's what I have done here. I know it was a bit ambiguous. I mean, it was not very clear, but now I think it's okay now. So you don't have to do this every time. If you are giving the force, same force on either side, you can use the direct equation directly by substituting this force, and the value you get for x is the total extension of the string. Okay, right. Amani said, I hope you understood it. Only two of them have responded. Right. Amani said we should substitute 2 mg. It's not like that. You can substitute mg and get the answer. Right. 13th one. 13th one is a question for people who have covered radioactivity. A good question. Activity of a radiating sample S1 is A naught. Activity of a radiating sample. So activity is A naught, sample S1. The number of radioactive nuclei in that sample is twice than that of a sample S2 with activity 2A naught. What is the ratio between the half-life times of S1 and S2? So many things are mentioned here. So let's do it this way. I'm going to put a table now. I'm going to put a table. Right. How do I start it? Wait a minute. Yeah. Sample. S1, S2. Okay. Let's start that with sample S1 and S2. First of all, activity. Activity of sample 1 is A naught. What is the activity of sample 2? 2A naught. Next. Number of radioactive nuclei in that sample is twice than that of the sample S2 with activity 2A naught. Therefore, number of nuclei, they are saying number of nuclei in S1 is double that of S2. So if I take the number of nuclei in S2 as N, number of nuclei in S1 is 2N. Do you understand? Read it again. The number of radioactive nuclei sample, the number of radioactive nuclei in that sample, who is that sample S1, they are talking about S1, is twice than that of sample S2 with activity 2A naught. Sample S2 has an activity of 2A naught. It has N number of nuclei. Therefore, sample S1 with activity A naught should have the double amount of nuclei. Ratio, okay. What is the ratio between half-life times of S1 and F2? Right, half-life. Half-life, we'll take it as T1, T2. Is this clear? So first of all, you have to understand these quantities for both the samples. Right, now let's start comparing. What are the equations, people? Now we have an equation for half-life. We have an equation for activity. Now, first of all, what is the equation for activity? Activity A, that is equal to lambda n. Agreed? Lambda n. This is the equation. What is lambda? Lambda is what you call decay constant. Lambda is decay constant. Right, let's start. Let's start with sample S1. For sample S1, if I put the equation, A is activity is A naught, that is equal to decay constant, it will take it as lambda 1. Lambda 1, n is 2n, lambda 1 into 2n. Equation 1. And S2, that is activity for S2 is 2A naught. Its decay constant is lambda 2. into 2n, sorry, number of nuclei is n, second equation. All right. So if I divide the second one by first one, I will be getting 2 equals lambda 2 over 2 lambda 1. Lambda 2 over 2 lambda 1. Therefore, finally, we will get lambda 1 over lambda 2 come to lambda 1 over lambda 2 is equal to 1 over 4. I take lambda 1 up, lambda 2 down, this 2 comes down 1 over 4. Right. Now I have now why did I write this equation? Because I needed to connect activity and number of nuclei. They are lambda jumped in. Lambda is a decay constant. But the question is, what is the ratio between the half-life times of S1 and S2? That is T1 over T2. That's the question. Can someone tell me the relationship between T and lambda? What is the equation? People who have done radioactivity. What is the relationship between half-life and decay constant? Can anyone remember? No? Hello? No? Right. I'll write the equation then. Half-life is given by ln2 over lambda. Hope you can remember. It is ln2, if not 0.693 over lambda. Does it ring a bell? This is the equation. So 0.693 is a constant value, people. That's a constant. Therefore, you can say half-life is proportional to lambda. Sorry, inversely proportional to lambda. My God, inversely proportional to lambda. Okay, so for sample S1, if I write the equation, it will be T1 proportional to 1 over lambda 1. For sample S2, if I write the equation, T2 proportional to 1 over lambda 2. Question is T1 over T2. Let's divide them. When I divide T1 over T2, I'll be getting 1 over lambda 1 over 1 over lambda 2. Final answer, lambda 2 over lambda 1. This lambda 2 will go up. Therefore, T1 over T2 will be equal to, what is lambda 2 over lambda 1? 4. Lambda 1 over lambda 2 is 1 over 4. Lambda 2 over lambda 1 is 4. Therefore, for 13th question, answer is 5th one. Right? How many of you tried this? Eye ring is the appropriate position to keep the eye when observing through an astronomical telescope. In which of the following the magnitude of the aperture of the eye ring does not depend? What is the meaning of aperture? Aperture is like the diameter. Okay? Diameter means it's the size of the hole. So I'll say diameter. Larger the diameter, larger will be the aperture. If you are using a camera, you will have heard of this word, aperture. Aperture means the size of the opening. Now, if you want the camera to function well in dark, what is meant by frontmost part here? Frontmost part. What is frontmost part? Frontmost part means the. Now, if you take a lens, Malaysia, it will look like this. This is what they mean, I think. The size of this frontmost part. This is what they mean by that. The diameter, let's say. Now for this, I think you have to go for the definition of eye ring. What is the definition for eye ring, people? What is eye ring? Eye ring is the image of objective lens created by who? Eyepiece. So I don't know, it will be created somewhere here. Let's say it's created somewhere here. It's created somewhere here. Okay, so we have to consider this as the object height, simple H. This as the image height, capital H. Because this is like the object. This is the object lens. Wait, I'll write. This is the object. This is the lens. This is the image. That's how it works. And wait a minute. And people, what is this? This is the object lens. Object lens becomes the object. Eyepiece becomes the lens, and the image is eye ring. That is the best place to place your eye. So the size of the eye ring means we are talking about capital H and simple H and all those things, right? And now normally under normal adjustment, we are talking about astronomical telescope means normal adjustment. What is the length between these two? What is the distance between these two? It is a fixed value. Now what is it? It will be FO plus FE, correct? FO plus FE, and there will be an image distance. We don't know that. We'll take it as V, and we can prove that actually. We can prove that. Now, the magnitude of the aperture means we are talking about capital H. The magnitude of the aperture means we are talking about that capital H. Capital H is larger, the magnitude of eye ring is larger. So capital H will depend on what, people? Tell you. Size of the frontmost part of the object lens. That's correct. Because if the object is large, image will be large. If the object is small, image will be small. Because V will be constant enough. Now, why is that? When you apply 1 over V minus 1 over U equal to 1 over F for eyepiece for this situation. All right. 1 over V is the position where the image is formed. 1 over V. I'll put minus for that because it is formed on the right side. Minus 1 over U. What is 1 over U, people? FO plus F equal to 1 over the lens we are using is eyepiece. Lens we are using, lens is eyepiece. So minus FE. If I can multiply everything by minus, therefore I'll be getting 1 over V, and you can take it to the other side. 1 over FE minus 1 over FO plus FE. You can take FE over FO plus FE as the common denominator. Therefore, here you will be getting FO plus FE minus FE. Therefore, FE will get cancelled out. 1 over V will be equal to FO divided by FE within brackets FO plus FE, and which will give you V equals FE into FO plus FE divided by FO. You must have done this many times. Even in one of the previous papers, we came across this. Now, what is the magnification? Angular magnification? No, linear magnification. Simple. That is equal to V over U. And that is also equal to capital H over simple H. And what is V, people? What is V? V is this FE, FO plus FE over FO. And what is U? FO plus FE equal to capital H over simple H. Therefore, you can say FO plus FE will get cancelled out, guys. And finally, you will arrive at an equation like this. You don't have to do all these things. Just assume that you got an essay question and you wanted to prove this in case. So capital H is equal to, finally you get a very small equation. Simple H, FE over FO. Simple as that. Now we want this capital H to be as large as possible. So capital H is depending on simple H, the focal length of object lens, the focal length of eyepiece, everything. Yeah, these are the 3 points. Simple H is the height of the object lens, or half of the diameter. FE is the focal length of the eyepiece. FO is the focal length of the object lens. Right? Put your hands up if you understood this derivation. Arya. I did the simplifications a little fast, I know, but I think that's manageable. Right? Okay, let's go now. Size of the frontmost part of the object lens. Yes, that's correct. Size of frontmost part of eyepiece. What about that? That doesn't have anything to do with this, no, people. That doesn't have anything to do with this. Because the size of eyepiece did not get involved in this equation. I don't see that involved in the equation. Okay. Therefore, for 40 looks like the answer. This is no. Size of frontmost parts of the eyepiece means the height of eyepiece. It is not there in the equation. Okay. Now H is half diameter of object lens by 2, and FE its focal length of eyepiece. Blah 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 blah. You know that. Focal length of objective. Yes. Focal length of eyepiece, yes, 1, 2, 3, okay. Distance of the object, distance of the object. Now, second is definitely the answer. That means I need to give you an explanation about the fifth one. Why is fifth one okay? I think the reason is, now we derive all these equations. Now we take FO plus FE for what condition? Which object do we observe using the telescope, people? All these things we do when object is at infinity, no? When object is at infinity. If you bring the object to a finite length, you can't use all these equations. It becomes different, doesn't it? It becomes different. So that's what I'm thinking. Because when the object is at infinity, you get the image formed by objective lens at its focal point. But if the object is at a finite length, not very far from your telescope, for example, then you can't apply these concepts. So that's why I think it depends on that. It depends on that. Okay, to give you an explanation here, the telescope is at normal adjustment. Telescope is at normal adjustment when object is at infinity. If the object is at a finite distance, equations will differ. Now it's like this, people. You don't have astronomical telescope. If you are not looking at the sky, you are looking at somewhere else, somewhere close, then it will be different. Okay, Malaysia, did you answer your question? Did you put the fifth answer? I know fifth one is a bit problematic, but I think the second one is the best choice here. It doesn't involve in the reaction. Sorry, it doesn't involve in the equation also. 15th one. Which of the following is true regarding current electricity? True, huh? True. When a constant current flow is in a conductor, I hate when people use no any together. No net electric force acts on the moving electrons. Do you think that's correct? That is wrong, people. That is definitely wrong. Tell me why. Because now imagine you have a conductor. Now the entire this thing will be a conductor, but never mind. Conductor, and you have connected it to a battery. Inside this, who will be moving? Electrons are moving. No? The negative electrons are moving. We all know electrons will get attracted. Now, this is the positive terminal of the battery. This is the negative terminal of the battery. This positive terminal of the battery creates a potential difference. If there is a potential difference, there will be an electric field. So it's like you can consider it as if there's an electric field. Positive plate, negative plate, like that. No? The electrons will get attracted towards the positive plate. So if there's an electric field, obviously on the electrons, there will be an electrostatic force. Hope you guys understood that. Okay. So you can't say there is no force. There will be a force acting. And there will be a resistive force too, but we can't say net force is zero. If the net force is zero, electrons will not be moving. For the electrons to move, they should have a force acting on them. So A is wrong. No net electric force, no net electric force. Electric force, people, electric force. So there's only one electric force is acting. There is no other electric force. Maybe there is this resistance it gets from the positive charges, but that's not an electric force. So there's only one electric force, which is because of the electric field created by the battery. So we can't say no net electric. A is wrong. A is wrong. If A is wrong, first one can't be the answer. Fourth one can't be the answer. Fifth one can't be the answer. In a particular conductor, the work that should be done in order to move a certain amount of charge from one end to another end across conductor is a constant. Let's get back to, let's start 15th fresh. Which of the following is true regarding current electricity? When a constant current flows, when a constant current flow is in a conductor, no net electric force acts on the moving electrons. I said that is not accurate. That's wrong. The reason is this, people. The reason is when there is a conductor, inside that conductor there are electrons. There are electrons, and when you connect that conductor to a battery, there is an electric field created by the battery. Positive terminal, negative terminal. So here it's like a positive high potential, low potential. Therefore, the electron inside, the electron will experience a electrostatic force. And there are no other forces to counter this force. I mean, they are saying net electric force 0, but what is the other force which is going to stop this? Counter this force. There is no. So there is, that's incorrect. Since that's incorrect, we can say first is wrong, fourth is wrong, fifth is wrong, either second or third. In a particular conductor, the work that should be done in order to move a certain amount of charge from one end to another end across the conductor is a constant. I don't agree with that also. Why? Let me explain. Now, work done is equal to Q dot delta V. Q dot delta V, okay? So when you have a conductor, work done will depend on what? Delta V, right? If voltage across conductor changes, work done will change. Voltage across conductor changes, voltage across conductor changes, work done will change. They have not told a constant work done will change. They have not told constant potential difference. No. Certain amount of charge, that's okay. Certain amount of charge means Q is constant. According to the statement, Q is constant. But there is no mention about potential difference. If you change the potential difference across the conductor, then definitely the work done is going to change. Therefore, B is incorrect. If B is incorrect, there is no answer. There is no answer. They are asking for the true statement. There is no answer for this question, so let's go with all. I think that's why the answer is all for this question. 15th one, if you look closely, all. All right. 16th one, electrical. Sorry, see, electrical pressure is the electrical potential. That's correct. I think that is correct. That statement is not used much. Electrical pressure. Electrical pressure, it's like the water pressure. If you want water to flow from one end to another, you need a pressure difference. Likewise, if you want current to flow from one end to another or electrons to flow from one end to another, you need an electric potential. Always they say this, compare the flow of electron to flow of water. If you want water to flow, you need a pressure difference. If you want electrons to flow, you need a potential difference. Therefore, C can be taken as correct. C can be taken as correct, but there's no such answer. C only. 16. Which of the following ray diagram correctly shows a convex lens acting as a magnifying glass? Magnifying glass means the normal diagram we draw is like this. People, we need to take a convex lens. We place the object inside F such that it will create a magnified upright virtual image. This is the diagram. Right? Yeah, the good diagram goes like this, and then this, and then drag them both. Sorry. Yeah. Which answer is correct, people? Third one looks the best to me. Third one, no? Third one, because the image must be formed on the same side of the object, and it should be an enlarged or magnified image behind the object. Now, all these are wrong, definitely, because we can't have the image on that side. We need to have the image on the same side, but behind the object. Definitely, third is a very straightforward question. Now, I will move on to the 17th question. Right, 17th one. Okay, 17th question is okay, easy. What is the current through the cell if the internal resistance of the cell in the circuit is negligible, so it doesn't have R. Okay, now I see this part. So that part is very important, people. Whenever there is a short circuit, you should see whether the current can avoid the resistors and flow. See, now I'll mark it in blue color, the path of the flow, current flow. It can go here, current can go up to here, then current will go here, and current can avoid both the resistors and go here, go this way, right? Current doesn't have to go here. Why? There is a short circuit. Again, current can avoid these two resistors and go this way. If there is a path where current can go without flowing through the resistors, current will always prefer that path, because the path I have indicated, except for this, the other paths I have indicated zero resistance path. Therefore, zero resistance path. Current will avoid this, and these resistors are short circuited. None of them will work. That is the idea they want you to figure out here. None of them will work. Okay, so you should not do Kirchhoff's law. Oh, please don't do that. Don't put I1, I2, I3. Don't make a mess. This is it. The blue color part is the only part where the current will flow. Therefore, finish it. Put sigma I equals sigma IR. One battery E. Current I is flowing through R, IR. Therefore, current is what we are supposed to find. Yeah, I is equal to E over R. Very easy. Fifth is the answer. Whenever you have short circuit paths, be careful. See if current can flow current can flow by avoiding resistance. Yeah, done. The figure shows a conical pendulum of length d performing horizontal circular oscillations with R. If the angular frequency of the motion is omega, the value of omega square. Wow, that's very easy, but you have to be a little careful here. Very little careful. Okay, we know there are forces which are going to act here. How many forces will be acting, people? There's going to be an mg here acting downwards, mg, and there's going to be tension, T. Mark it here, this T, tension. And we can take components of that tension, right? And that this is, okay, I'll take this angle as theta. Right. So there will be a vertical component of tension. That is going to be, no, wait, what is this vertical component, anyone? Vertical component is going to be T cos theta, because if this is theta, this is also going to be theta. Alternate angle. And this force, that is going to be T sine theta. T sine theta. Finish, that's it. And then we have to start. How do you start it? We know for equilibrium, upward force is equal to downward force. The upward force is T cos theta. T cos theta is equal to mg. Therefore, T is equal to mg divided by cos theta. You can start there. And then there's only one way to find omega square. What is that? Applying the equation for centripetal force. Right, let's do that quickly and finish it off. Centripetal force is equal to mr omega squared. Why am I using mr omega squared? Because they are asking for omega. I didn't use mv squared over, because the question is about omega squared. Centripetal force, what is centripetal force, people? T sine theta, correct? T sine theta is the centripetal force. Mr omega squared. For T, you can substitute mg over cos theta into sine theta equal to mr omega square. M will get cancelled out. Right. Finally, you will arrive at an equation for omega square. What is the value, people? Omega square is equal to sine theta over cos theta. What is it? Tan theta, right? So G tan theta over R. G tan theta over R. What is tan theta, people? What is tan theta? I have a triangle like this. This is theta, this is hypotenuse, this is R, and this length is D. So I need this length. What is this length? This length. This is going to be square root of D squared minus R squared. Careful. D squared minus R squared. Pythagoras theorem. D squared minus R squared. So tan theta will be equal to G over R into R over square root of D square minus R square. Therefore, R and R will get cancelled out. And finally, you will end up in fourth answer. Omega square is equal to G divided by square root of D square minus R square. Fourth. Okay. Right. 19th question. Ice cube of mass M1, which is at 0 degrees Celsius, is mixed with the water of mass M2 at 100 degrees Celsius. Which of the following lengths of thick line correctly shows the values that can be taken by M1 and M2 such that the final mixture contains only water at final temperature 0 degrees Celsius. This is the key part. Final mixture contains only water at final temperature 0 degrees Celsius. Right, you should have only water at 0 degrees Celsius. Now, I think what I understand by these answers is this length represents M1. This length represents M2. Here, this whole length represents M1. And this small length represents M2. Okay. Here, this just very small length M1. And here, larger length M2. So, this is what they are saying. A very different interpretation, but you get the point, right? Right. What's happening? You have ice and water. You are mixing ice. Wait. M1 mass of ice at 0 degrees Celsius with M2 mass of water at 100 degrees Celsius. And what is the final mixture? You have just water at 0 degrees Celsius. What has happened? All ice has melted. All ice has molten or melted and become water. And all this water which is at 100 degrees Celsius, what has happened? It has cooled down. It has cooled down to release heat. Okay. So, M1 mass of ice at 0 degrees Celsius has become M1 mass of water at 0 degrees Celsius. Heat gained or heat lost? This heat gained, Q1. And M2 mass of water, which is at 100 degrees Celsius, has cooled down to same mass of water at 0 degrees Celsius. Sorry, this should be 0 degrees Celsius. Because finally we have 0 degrees Celsius water. Yes. And what is happening here? Heat is lost. It is lost by this water, Q2. And we can say Q1 is equal to what? Q2. Hot water is losing heat, ice is gaining heat. But ultimately both are becoming water at 0 degrees Celsius. So Q1, that is ice melting, equation is going to be M1 LF fusion equal to Q2 is water. That is mass of water, specific heat capacity of water, change in temperature of water. So M1 into LF, we know people it's 3.3 into 10 to the power 5. You should roughly remember the value. If not, you can't do this question. They have not given that. Equal to MW, mass of water is M2. Specific heat capacity of water is 4200. Change in temperature 100 minus 0. M1 into 3.33 into 10 to the power 5 equal to M2 into, this one can be written like this. 2 into 10 to the power 5. See, 1, 2, 3, 4, 0, another one. So these two get cancelled out. I'm getting M1 over M2, right? Okay, to finish it off, now M1 over M2, that is going to be equal to how much, people? M1 over M2 is equal to 4.2 over 3.3. That is 42 over 33. That is 14 over 11. 14 over 11. So M1 is slightly larger than M2. M1 is slightly larger than M2. If you look at the diagrams, I think the second one is the most appropriate. Do you agree with me? Second one. Yeah. And this is how we have to approach it. And yeah, finally, you both 100 degrees Celsius water, it's becoming 0 degrees Celsius water. Ice has molten and becoming 0 degrees Celsius. the 0 degree Celsius water. You just have to consider the heat transfer. Right. Question number 20. Another interesting question. Question number 20. Let's get started. The refractive index of glass block ABCD shown in figure is N. So here refractive index is N. All right. A light ray which incident on AB at point E enters the block and incidents on the side AD and grazes along AD. What is the refractive index of the liquid? Now there is a liquid here. We need to find the refractive index of that. We'll take it as NL. Can someone tell me what is happening here? What is happening? What is this angle, people? What is this angle? What is this angle? This is the refractive index. Sorry, this is the critical angle. I'll put GA, glass air interface. Do you agree? Glass air interface. Because the refractive angle here is 90. Therefore, definitely this has to be the critical angle. Never mind. Okay, fine. GA. Okay, CGA. If not, we'll put it as C. Never mind. C. We'll take it as C. And then again, the ray is incident here. What is this angle? Can someone tell me quickly? If this angle is C, people, this is C. What is this angle? What is that angle? It is going to be 90 minus C. Yes, 90 minus C. Sorry, 90 minus C. This question is very easy. All you need to do is apply Snell's law at point E and at this point. That's it. Finished. So if I start from this at this point, equation is N1 sin I1 equals N2 sin I2. Remember, this is air. Now let's pretend that you can't remember the equation for what do you call that? Critical angle. Just let's start fresh. Sine. This is 1 into sin I1 is sin 90 equal to N2 is the refractive index of the glass N into sin I2, that is sin C. So from that we know sin C is equal to 1 over N. And if I apply the equation to this point, N1 sin I1 equal N2 sin I2. Now even if I don't write this, you all know this equation. No? You all know this equation. When air and another medium are taken into consideration, this is the equation for the sine value of critical angle, 1 over N. N1 sin I1 equal to N2 sin I2 for this point. N1 is N, careful, into sin 90 minus C equal to N2 is the refractive index of the liquid, that is NL, into what is the angle? Again, it is grazing the surface. Again, it is grazing the surface. So this is 90. Again, the critical angle here, 90. Therefore, I just put sin 90. On the left side, N into what is sin 90 minus C, people? Cos C equals NL. Right? Fine. Put your hands up if you know, if you're okay with this change. Sin 90 minus C is cos C. Put your hands up quickly if you know that. Math students will know. I know there are a few math students here. You people, it's simple, but even for biology students, you should know this from your early physics lessons. Sin 90 minus theta is cos theta. Sin 90 minus theta is always equal to cos theta. That's what I've done here. So NL is what I'm supposed to find out. I have N and cos theta. Now, how do I find cos C? Look at this. I know sin C. Then you draw a triangle. You draw a triangle, a right angle triangle, and you put C here, right? C. What is sin C, people? Sin C is opposite over hypotenuse. Opposite over hypotenuse. Therefore, this side should be hypotenuse squared minus opposite squared. 1 over 1 squared, right? Agreed? And what is cos C now? Tell me cos C. N into cos C is adjacent square root of n squared minus 1 over hypotenuse n. So n and n will get cancelled off. Finally, NL will be equal to square root of n squared minus 1. Hence, the answer is first one. That's the answer for the first one. Question number 21, people. In a circuit given, the internal resistance of the electric cells of EMF E0 and E1 can be neglected. Okay. If there is no current flow through the cell of EMF E1, right? The ratio E1 over E0. A very easy question, this one. There's no current through E1. That means I can mark the current through this loop only. Right? This loop only. Done. And there's no current through this loop. No current through this loop. That means this R is useless. R is useless. Okay. Right. So what can we do here? We need to find out E1 over E0. I'll quickly put the letters A, B, C, D, E, F. Right. Now I'm going to apply Kirchhoff's law quickly. Delta E equals delta IR. Delta E equals delta IR. And what should I find? E1 over E0. No? Right. I'm going to apply the equation such that E1, only E1 is going to be involved. So for that, I need to apply the equation for the loop FD A B C E F in this direction. Correct? The outer loop, the outermost loop. When you do that, sigma E is just E1 equal to how many resistors are involved in that? 2 resistors, right? 2 resistors, R and R. So I can put how? I into 2R. Agreed? If not IR plus IR. 2IR. First equation. Only E1 is involved. I ignored this part so that E0 won't be involved. First equation. And then I'm going to apply the equation for DABCD loop, where E1 will be ignored. So you will be getting E0 equals current is flowing through 3 resistors. R. 3IR. Second equation. That's it, people. See how easy this is. Then 1 over 2. That is E1 over E0. 2IR over 3IR. That is 2 by 3. Third answer. You should do this in like 2 minutes maximum. Not even 2 minutes, 1 minute. 21. Third answer. 22nd question. Right. The nearby graph shows the variation of electric potential in a region with the distance d along a straight line. In which of the points on the straight line, the magnitude of electric force acting along the straight line on a point charge will be maximum? Maximum. Right. Now, electric force is equal to QE. We have studied that. So Q is a constant. They are talking about a particular charge on a point charge. If Q is a constant, that means the electrostatic force which is acting on that charge is proportional to E. Let me convert this diagram to E versus D diagram. E versus D diagram. Let's see how many of you can remember. E versus D diagram. That's what I'm going to do. E. What is the relationship between E and V? We know E is equal to minus dV over dx. E is the negative of potential gradient. The gradient of this graph, but the negative side of it. All right. Fine. So I have some points. This is P. This is going to be Q. This is going to be R. I think this is R. S. T. I think this should be T. Yeah. Stop here. R starts here maybe. Now, and from P to R, graph is going down, but it's a flatter graph, that not very steep. Therefore, E will be like this until R. And after that, the graph is going up. When you convert a VD graph to ED graph, if the graph is going up, E will be positive. If the graph is going, if the graph is going down, VD graph is going down, E will be positive. If VD graph is going up, E will be negative because of this negative sign. Here, it is steeper, correct? Here it is steeper. Therefore, you will get a value for E like this, larger value, much even larger, like this. and that starts, I think, at this point. R is on the other side of that point. T is here, right? And that keeps, continues to go because the graph is extending this. So tell me now, Vibha, they're asking for the magnitude, right? Point charge will be maximum. Magnitude of electric force. So magnitude of electric force depends on magnitude of E. Which E is larger? This one is larger, no? The bottom it's larger. You can see the bottom it's larger. Therefore, where will it experience the highest force? Fifth answer. At R, ST. At all those points, E is constant and high value. Not only R or T, R, ST everywhere. Now at SV0, that doesn't mean electric field intensity is 0. You can't say that. Now this is a negative value, negative, and here positive value. So for example, imagine this V value, voltage. Voltage. Let's say this value is like 4 volt plus 4 volt. This is like minus 2 volt. So if I draw the points R and T, T is like at T is at plus 4 volt. R is at minus 2 volt. Therefore, there will be an electric field from T to R, like this. Constant electric field. Yeah? That's what I have marked. That's why it's in negative direction, because it's towards left side. Anyways, 50 is the answer. Moving on, 23rd one, right? 23rd one is an interesting question. Let me explain that quickly. An electric bulb of 40 watt is connected in series with a room heater, which is under major electric supply. Major electric supply means that 200 volt supply, probably. If that electric bulb is substituted by another electric bulb of 100 watt, which of the following is true regarding the activity of the heat? Now, guys, 40 watt bulb and 100 watt bulb, we have to understand about them. Imagine you have a battery. And you are connecting the bulb to that battery. Same bulb, same battery. I mean, if not, I'll forget about the battery. You take that 240 volt supply. 240 volt supply. You connect the bulb to that. 40 watt. And the other bulb, 100 watt. It is also connected to 240 volt supply. What is the difference between these two bulbs? Can anyone tell me? Now, both the bulbs are going to experience the same potential drop, no, people, 240 volt. Okay, 240 volt. So if I take the resistance of this bulb as R1 and R2, tell me about the resistance, people. Now you see power. Power is equal to V squared over R. I'm using this equation because I know the voltage. If I supply the same voltage, this should show 40 watt, this should show 100 watt. Therefore, tell me, voltage is constant because same voltage is supplied for both, but they should show different powers. So if you want the power to be high, resistance should be, if you want the power to be high, resistance should be, answers please. Resistance should be low. Resistance should be low. Okay. So you need to know one thing, resistance. Resistance of 40 watt bulb will be greater than 100 watt bulb. This is why, 100 watt bulb resistance will be less. So it can glow brighter. It will allow more current to flow through it. It can glow brighter. More current will flow through this because it has low resistance. So it will glow brighter. You might have noticed if you go for 100 watt bulb, it's brighter than 40 watt bulb. The reason is this: it will have low resistance, so it will allow higher current to flow through it. Now, what is going to happen? Now let's go back to the question, people. I just wanted to explain you the difference between 40 watt bulb and 100 watt bulb. I hope you understood it. Wherever the power is high, resistance will be less. Now, again, let's go for the same concept. I have a bulb, I have a heater, and I have connected it to 200 volt power supply, same voltage. And then again, I have another bulb and heater, but the power supply is same. 240 volt. Tell me what will happen, people. The heater, this is the heater, huh? Heater will have a constant resistance. No? It will have a fixed resistance. I'll take it as R0. And this is, let's say, this is the 40 watt bulb. 40 watt bulb. Huh? This is the 40 watt bulb. This is the 100 watt bulb. We all know 40 watt bulb is going to have high resistance or high. 100 watt bulb is going to have low resistance. And I think in the question they have mentioned the fact that they are connected in series. I read it. Connected in series. See, connected in series. So I put them in series. Now in this series, in this circuit, there will be a current I1. In this circuit, there will be another current I2. Tell me which current is larger, I1 or I2? Hurry up. I want answers from everyone. Which current is larger? Obviously, I2 will be larger. Yes, I2 will be larger. I2 will be larger. Okay, I2 will be larger. Right. Okay, wait, what are we asking? Lucas question. Wait. So, but potential difference would be same, na? So, how can current differ? Potential difference and now potential difference is same. If you want the current to be same, resistance must be equal. Then only current will be same. So these two won't have the same resistance. We can't say the current is different. Sorry, resistance is same. We can't say that. We have to consider the resistance. It's a must. And for a bulb to glow brighter, more current should flow through it. So low resistance. Anyways, so what will happen here? What is the answer, people? What is the answer? Which of the following is true regarding the activity of the heater? True regarding the activity of heater. 40 watt battery, and then you replace it with 100 watt battery. If more current flows through the heater, output will be increased, correct? Output will increase. What's the reason? Because more current flows through heater. There can be good side and bad side to it. Why? If more current flows through heater, if it gets overheated, it might burn. But if that current increases and if it is within the optimum level, then it's going to function better. But anyway, output will increase. Output of the heater will definitely increase. And this is how you compare. Right? I think the takeaway from this question is, if you couldn't get the answer, don't worry much. You need to learn from each question in a paper class, people. So what you can learn from this question is, when they have given you two different batteries of two different power ranges, you have to figure out that their resistance. The one with the higher power range has low resistance. The one with the lower power range has high resistance. Use that concept and attempt the question. 24th one. The maximum tensile stress that can be withstood by unit area of a substance without affecting that substance called tensile strength. The tensile, I think there's a printing error here. It should be tensile strength. Yeah. Tensile strength. Should be tensile strength, people. You can't do this question. Tensile strength of steel. Because if you mention something for a material, it's going to be a fixed value. Strength of steel is 450 megapascal. What is the maximum mass that can be hung from a vertical massless steel rod of diameter 2 centimeters? Right, let's finish it off. It's going to be pretty easy. This. And what is the mass? We have to find the mass. So I've hung a mass. Let's say that is capital M. So the force I'm creating is mg. Diameter is 2 centimeters. Diameter 2 centimeters. Okay. Then radius 1 centimeter. Equation, people. Equation is going to be stress equals force over area. The maximum possible strength which could be withstand by weights 450 megapascals, so 450 into 10 to the power 6. Force mg, we don't know m, we need to find m. And over area, you have to put pi r square. So force over area means force over pi r square. What is pi r square? 22 by 7 into r square, 1 square, 1 centimeter square. That means 1 into 10 to the power minus 2 square. Okay. Mg, therefore I can cancel out one of the 10s here, 10, and this becomes 10 to the power 5. Therefore, capital M is equal to what, people? 415 into 22 by 7 into 10 to the power 5 into 10 to the power minus 4. Did you multiply this? What is the answer you're getting? 400, it's roughly 60. Anyone multiply this? Third answer. Anyone else? Guys, this is very easy. No one did this. Okay. So capital M is equal to. No need. You don't have to do that. Tensile. No, answer is given as megapascal. So they have given you the stress. They have given you the stress, so you don't have to divide by area again. So capital M is going to be equal to, people, roughly 13,000 kilograms, it seems. 13,000 kilograms. I didn't multiply it. Right, that's the value. So third, roughly that value. You can't say it depends on the length. It doesn't depend on the length. You can directly substitute this. You don't have to go for Young modulus and all. You can just say lambda maximum. They are asking for the maximum force. No, okay. What I should have done is they have given you maximum stress, possible stress. That is maximum possible force over pi r square. So what I have put here is actually the maximum possible mass, M max, because force is maximum. All right. That's it. So the answer is third for this. Moving on, 25th one. So we have come halfway. Right. This is also an interesting question. I hope you guys tried it. Let's start. A point mass is pasted at an unknown position of a narrow massless vacuum tube of length L. So this part, it is massless, right? Rod is allowed to perform small oscillations of period T above a frictionless horizontal axis at one end of the rod. Here, this one, they have fixed it, fulcrum. Similarly, when the rod is allowed to oscillate about the other end, this end, oscillation period is 2T. What is the distance to the point mass from the center? From the center. Careful. Okay. Now, first of all, you have to mark the center. Center. I'll mark few lengths quickly. I'll take the total length of the vacuum tube as capital L. Capital L. And I will mark the length which I'm supposed to. Okay. Yeah. Which I'm supposed to find out. X. This is the center. All right. So what is this length? This is going to be L by 2. This length is going to be L by 2. Remember. And from the center, what is the distance to that point? Right. And what is this length now? This is going to be L by 2 minus X. That is this length. L by 2 minus X. Our target is finding X, people, remember. Okay. Now for this situation, okay, there are two situations. I'll draw them separately. There are two situations, people. First situation, you are allowing it to oscillate this way. That, so you can compare it, a light string oscillating, a mass connected to a light string oscillating like this. Right? So there you can say T1. What are we supposed to find out? T. Period is T. So we all know T is equal to 2 pi root of L over G. Okay. 2 pi and G are constants because we did not go to another planet or we are not moving in a lift. So G won't change. 2 pi anyway constant. So T is proportional to square root of L. For the first scenario, T is proportional to, what is the length of this pendulum, people? What is the length? What is this length for the first scenario? L by 2 minus X. L by 2 minus X. Therefore, I can put that here. Square root of L by 2 minus x. So first equation, and they have given the initial period as t. Now the second instance, you are changing the ends. You are changing the ends and allowing the mass to oscillate. And now you will be getting a situation like this. Its length is longer and it's oscillating. Guys, tell me what is the length now? New length. The new length will be L by 2 plus x. This is massless, okay? So you can think of that as a string, massless string. This is the new, what do you call that? This is the new length. Now the period is 2t. Therefore, I can say second situation, 2t is proportional to square root of L by 2 plus x. L by 2 plus x. So what can I do now? I'll write it here. Second one divided by first one. On the left side, that will be equal to 2 equal to square root of L by 2 plus x over L by 2 minus x. X is the distance which we were supposed to find out. I have marked it as x. That way it's easy. Let's square either side. 4 equals, what can I do, Vivan? We'll take LCM, maybe. Okay. L plus 2x over 2 over L minus 2x over 2, so that I can get rid of this 2. 2 gone, right? First multiply it, what will you be getting? 4L minus 4x equal to L plus 2x. Did I make a mistake? Oh, sorry. 8x, no? 8x, huh? Not 4x. Because I have to multiply L minus 2x by 4, no, people? 8x. Therefore, 4L minus L, that is 3L. 8x goes to the other side, becomes 10x. So x is equal to what? 3L by 10. Fifth answer. Good question, that one. A different one. For your later reference, I'll take this point as A, I'll take this point as B. When I say first case, I have hung it from point A. Second case, I have hung it from point B. That's what's happened. All right. Okay. Now we go to question number 26. We are halfway done. The frequency of wave emitted from a radar instrument is 750 megahertz. When this wave is incident on an aeroplane and reflect back. Okay, this is the question for reflected sound. Its frequency seemed to be increased by 2.5 kilohertz when observed from a radar station. What is the speed of aeroplane towards the radar? Velocity of light in air is 3 into 10 to the power 8. Now, there is an equation which you should remember to do these kind of questions quickly, because we are talking about reflected sound. That equation is this, people. When you have an object which is moving towards another barrier. Now here the barrier is the radar, right? No, wait. Aeroplane is moving. This is the aeroplane. Aeroplane is moving towards the radar. Okay. Sorry, wait. Radar. So from radar, sound waves will leave towards the aeroplane at an initial frequency of f0 f0. And when that wave reaches the aeroplane, it will not reach at f0 frequency, it will reach at f1 frequency, a different frequency. Because there is a relative motion between aeroplane and radar. Radar is at rest. Radar is not moving in. And then the sound wave will hit the aeroplane and it will bounce back at same frequency f1. And when that reflected sound wave reaches radar, it will be reaching at f2 frequency, f2. And the equation for that f2 is, let's say the aeroplane is traveling at a speed of v. The equation for that f2 is f2 equal to c plus v over c minus v into f0. If you can remember this, you can do your MCQs quite conveniently. F2 is the reflected sound reaching the radar. Reflected sound reaching the radar. How many of you can remember this equation? Put your hands up. Right, I can see a few hands going up. Oh, okay, good. Around 9 to 10 hands going up. Okay. If you remember this, it will be really helpful. If not, every time you do a question, you will have to derive it, people. That is going to be a headache. If you want me to derive it, I will derive it and show you. So let's start with this. And what is the question now? See, the frequency of wave emitted from a radar instrument is 750 megahertz. So F naught is 750 megahertz according to the question. F naught is 750 megahertz. That is 750 into 10 to the power 6 hertz. When this wave is incident on an aeroplane and reflected back, its frequency seems to be increased by 2.5 kilohertz. So what they have given us is F2 minus F naught is equal to 2 kilohertz. That's what they have to. And that is in fact 2000 hertz. Okay, right. So first of all, let's use this equation and do the question. And what I'm supposed to find out, what is the speed of the aeroplane towards the radar station? So this is a technique we use to find the speed of the aeroplane. From the radar station itself, you can estimate the speed of the aeroplane. So that's one of the main uses of Doppler's effect. Okay, I'll use this equation now. F2 minus F naught is equal to 2000. I'll start there. F2 minus F naught is equal to 2000. What is F2? That is the sound wave you sent to aeroplane and came back from aeroplane. F naught is the original frequency of the sound emitted from radar. And for F2, we have derived an equation that is this. C plus V over C minus V into F naught minus F naught equal to 2000. C is the speed of light here. V is the speed of the source, aeroplane. So F naught can be taken common, and then people, I will be getting C plus V over C minus V minus 1 equal to 2000. Then if not, I will take C minus V as the common denominator, which will give me C plus V minus C minus V equal to 2000. If not, within bracket, what will I get on top? C minus C will cancel out each other, gone. V minus minus V, so it's V plus V, we get 2V over C minus V equal to 2000. Remember, you are supposed to find out V. Okay, don't forget who you are supposed to find out. Look at the answers, people. Look at the answers for V. 4 kilometer per second, 2 kilometer per second. Now, C is 3 into 10 to the power 8 meters per second. That is 3 into 10 to the power 5 kilometer per second. Kilometer per second. Therefore, if you subtract V from C, it is going to be a negligibly small value. Therefore, you can write this 2V F naught over C equal to 2000. Why? Because C is much larger compared to V. See, look at the value of C and look at the answers for V. 10 to the power 5. So, subtracting these things is ridiculous, stupid. We don't have to do that. We can take it this way. Therefore, V finally will be equal to, no, you can simplify a 2 here, 2 and a 2000. 2 and the 2000, if you simplify, you'll be getting 1000 here, 1000. Therefore, V is the final answer we need to figure out. V is equal to 1000 C over F naught. 1000 into C is 3 into 10 to the power 8 over F naught. What is F naught? 750 megahertz. 750 into megahertz, 10 to the power 6. What are we getting, people? I think 4 is the answer. No? 4 kilometer per second, anyone? 4 kilometer per second? No, okay, wait, I think I made a mistake somewhere. What is the mistake I made? It's 2500 people. 2500. 2500. Sorry, I have not seen your message. It's 2500. 2500. 2.5. That means this is 2500 hertz. So I have to change everything to 2500 quickly. 2,500 here to 2,500. So I'll redo this part. Sorry. And written as 2FV over C equal to 2,500. That is because C is much larger than V. So V is equal to 2,500 C over 2F0. 2,500 into 3 into 10 to the power 8 over 2 into F0 is 750 megahertz. 750 into 10 to the power 6. If you simplify that, what are we getting? Wait, I think with 750 I can cut. With 750 I can get rid of 750. 3 into 250. 3 into 250, so 3 gone. The 250 gone. I'm getting a 10 here. 10. 10 there. Yeah. Yes, and the final answer is 500 meters per second. But the answers are in kilometers per second. 0.5 kilometers per second. Fourth one, fourth one. Right, fine. Now, I'm not going to derive this. Most probably you might have done this at your theory class. So please go through this and revise it and remember this equation. That way you can save awful lot of time. Deriving it will take some time in vain, 1 or 2 minutes in vain. If you know this quickly, you can put it and use that to your question. So at essay, you'd be deriving. When you do essay questions, you have to derive it. Most of the Doppler effect questions, we have to derive it. Now they will guide you step by step. Find this, and finally you will arrive at this equation, and finally you have to derive this equation. I have seen a few Doppler effect past paper questions also. Just have a look at that, right? Then you will understand it. Right. To talk about the 27th question, they are asking what is the tension acting here? Tension in the fixed end of the string. That means this. Or this one. Which one? This one. Or maybe this one. Right. Fixed end means this, right? Is it? Right. Never mind. Everywhere tension will be equal. Tell me why is that? Why will tension be equal everywhere? It is a massless pool and the other attached fixed point. What is it? Light string. It says light string. So tension equal everywhere. In fact, we are supposed to find out this tension, but that you can find it here. Same tension will be there. So mg. And if they ask you to find this angle also, you can find it. How is that? 2t cos theta is equal to mg, but we know t is equal to mg. So 2mg cos theta is equal to mg. Mg and mg will get cancelled out. Cos theta is equal to half. Cos theta is equal to cos 60. Therefore, theta will be equal to 60. That is the only other option they can ask. So don't think too much about it. 28th one. When a uniform electric field strength of E is passing across the Gaussian surface of radius r and length L perpendicular to the axis of the surface, what is the electric flux due to the electric field lines entering this region? Right. Now, electric flux means you need to find out the number of electric field lines going through the perpendicular area. Now look at the electric field lines. Now you should not get confused here. Now if you consider a situation like this, people. Now imagine you have a point charge. From a point charge, electric field lines will go everywhere. 360 degrees, 360 degrees. And those electric field lines are perpendicular to a spherical surface you draw around it. Got it? Because it will go up, it will go down, it will go to the east, west, northeast, northwest, everywhere. Therefore, if you draw a sphere around it, a spherical surface, all these lines are perpendicular to that spherical surface. So there you have to consider the area as the area of the sphere. Got it? And if you take a rod, which is charged, if you take a rod which is charged, tell me what is the area you should consider. If you take a rod which is charged, what is the area we should consider? Let's say you have a plus charge like this. What is the area I should be considering as the Gaussian surface? Cylinder, right? Cylinder. You have to consider cylinder because the electric field lines will go like this. It's a cylinder. Everywhere the electric field lines will go like this. So those electric field lines will be perpendicular to a cylindrical surface. Now here, if you take this one, you look at the electric field lines. Electric field lines are going straight. Therefore, you have to choose the area which is perpendicular to those lines, which is this area. The area I'm drawing. Do you understand? This is the area. Because the electric field lines are perpendicular to that area. Not perpendicular to the curved surface. No. The part I have marked in red color, that is the perpendicular area. Why did we take sphere as the area? If I now can draw a sphere here, it's a sphere. Here I can take sphere. Look at all those lines. They are perpendicular to the spherical surface. No? Here I can I can draw a cylinder people. Because these lines are perpendicular to that cylinder I'm drawing. But here, already the lines are given to us. Hence, you have to consider this area. Now, the question is flux. What is the equation for flux? Someone? What is the equation for electric flux? Flux is equal to, let's see who can remember. EA. Good. EA. Flux is equal to E is already given. For area, what should I put, people? I should use this area. And what is that area? Tell me. What is this area? Well, this length, that is going to be 2R. No, 2R length. That length is 2R. And that is a rectangle, mind you. That's a rectangle. So area will be 2R into L. Or 2 simple R. They have given simple R into L. It's a rectangular area. Therefore, you just have to multiply the width by the height. Width is diameter. Height is L. Therefore, the answer will be pi is not there. Pi is not there in the answer. 2RLE. Fifth answer, people. Fifth answer. 2RLE for 28, fifth answer. The reason is this. Already the electric field lines are given to you. If the electric field lines are already given to you, you need to choose the area perpendicular to the, should we take that plate area? What do you mean plate area? Yeah, plate area means the area I have drawn. The area I have drawn, you have to take this area. The area I have drawn in red color. I think most of you might have gone to the fourth answer. How many of you chose the fourth answer? Put your hands up. People who chose the fourth answer. Right. See, I can see some hands going up. And I hope you guys understood why it's incorrect. Yeah. Because the field lines are not going perpendicular to that area, people. The area you have taken is that curved cylindrical area. If the electric field lines were going like this, for example, I'll draw a cylinder like this and I'll try to explain it. Right? Imagine there's a cylinder like this. And when can we use that area? That's the question we have now. So let's draw a cylinder. Okay. Imagine a situation like this. Sorry. So if you want to use this, if you want to get this as the answer, what is the condition? The condition is the electric field lines should go this way, perpendicular to the curved area. So how to put that into diagram everywhere like this? Do you understand this, people? Do you understand this diagram? Hope you can understand this diagram. It's very difficult to draw 3D stuff. This way. Got it? I hope you can understand what's going on here. That means it's going perpendicular to that surface. All right. Right. Next question is the 30th one. 30th one. The figure shows an equal length of dry air. This is very important. The figure shows an equal length of dry air trapped by different lengths of mercury columns. Equal length of dry air. Okay. So initially lengths are equal. Initially lengths are equal. Remember, the lengths are equal. Therefore, I will take the temperature. Initially, maybe they are at room temperature. No? So when temperature, let's say temperature is equal to theta naught, something like that. Length is L naught. Length is L naught. Therefore, I will forget about the answers. I'll try to draw my own graph. Put the graph. Length versus theta at a certain value, which is the room temperature, maybe both the graphs have same length. Agree with me? L naught. Both the graphs have the same length. That is the first point. There's a point there. Both the graphs have that they have mentioned in the question. They are starting with the same length. Pressures are different. I totally agree with you. Now pressure will be different inside. But the problem with this question is, now here what is the pressure? Here pi. Here pi. This height will take it as h1. This small height h1. This small height is h2. Right. Now inside this pressure is P1. Inside this pressure is P2. Good. Now we definitely know who is larger. P2 is larger, no, people. P2 is larger because you can write P1 equal to pi plus h1 rho g. P2 is equal to pi plus h2 rho g. H1 is smaller than h2. So P1 is smaller than P2. Done. Agreed. Okay, fine. But the problem is they have not mentioned about the number of moles, people. Number of moles here, N1, number of moles N2. That's the problem in this question. Now, if I develop an equation for length versus theta, now this is the cross-sectional area. Let's say it's a uniform tube. Have they told it's a uniform tube? Equal length of dry, different lengths of mercury column in the quill tube. Let's assume that the area is constant A. Now what is the equation I have right here? PV equal nRT. And PV equal, since this is degrees Celsius, they have not said it is thermodynamic temperature or absolute temperature. We have to change nR theta plus 273.15, something like that. For volume, I can put P into AL. That's where the length comes. The length equal to nR theta plus 273.15 nR. Right. So length, that is equal to nR over PA theta plus 273.15 nR over A. Now, this is the gradient of the graph, nR over PA. The graph looks like what, people? Y equals mx plus c. L length is in y-axis, theta is in x-axis. And look at the gradient now. Gradient is equal to nR over PA. So people who took fourth, first, third, you have considered different gradients. But the problem is, in this question, they have not told n1 and n2 are equal. You can take gradient is proportional to, gradient is proportional to 1 over P only when n is constant. They have not told that n is constant. That's one problem. And the other thing, people, now what will happen when I put minus 273.15 for theta? What will happen? When I put minus 273.15 for theta, everything will get cancelled out. I mean, I think I have put missed a P here. P should come. So always remember, volume will become 0 when the temperature is absolute 0. When the value of theta is minus 273.15, what is the meaning of that one? Your gas can't have a volume, 0 volume. The gas should have 0 volume. So already there are 2 points, fixed points. 1 point for both the tubes. These 2 points are common for A and B. Okay. Yeah. I'll put X and I'll put Y. I'll say points X and Y are common for both A and B. Why is that? I'll repeat. At temperature theta naught, which is the room temperature, they both have same length. That's why I have marked this point. So this point is common for both the tubes. And this is common for any tube. Why? When your temperature is minus 273.15, which is 0 Kelvin, the volume of any tube, any gas will become what? 0. There won't be gas there, I mean 0. Volume will become 0. Therefore, length should become 0. Length of the air column should become 0. Therefore, since there are two fixed points, then you definitely have to draw only one straight line. Only one straight line. Therefore, the answer for this question is, people, fifth one. I know normally we never come across questions like this. We normally write this equation. Most of the times they will give you the number of information about number of moles. Based on that, we compare the pressure and number of moles and compare the gradient and choose the graph. But here they have not specifically told about number of moles. So we can't directly decide about gradient this way. So I will write it and I will just cut it with red color. You can't do that for this question because there's no mention about number of moles, right? Hence answer fifth. Next question. A large block of mass 5 kg is moving towards right with the velocity of 10 meters per second at a particular instance. For every 1 meter interval, from the block of mass 5 kg, small blocks of 1 kg, small blocks of mass 1 kg, which are initially kept at rest, are positioned. All collisions are inelastic. All collisions are inelastic. What is the meaning of that one? All collisions are inelastic. That means we can assume that the masses combine. Masses combine together. Masses combine together, okay? Masses combine together. Neglect the friction, okay? Neglect the friction. So we have to assume that the masses are combined. When two masses combine together and move together, then there will be energy loss definitely. So the collision is going to be inelastic. If it is elastic, the masses will not combine. What is the distance that can be traveled by the large block before its velocity decreases below 3 meters? So this is what's happening. We have a 5 kg object initially, 5 kg block traveling at a speed of 10 meters per second. And there's no friction here, smooth surface. And there are small boxes at 1 meter intervals. Okay, so the gap is 1 meter. 1 meter intervals, and the mass 1 kilogram, 1 kilogram. Okay. And what's going to happen as 5 kilogram keeps getting combined by each block, its velocity will reduce. So let's consider a situation where its velocity has become, I'll assume that the final velocity is 3 meters, 3 meters per second. Now its velocity has become 3 meters per second, and it collided n times. After n number of collisions. But I think I made a mistake here. For every 1 meter interval from every 1 meter interval from 5k. So that is, I'll draw another one. Initial velocity is 10 meters per second. So for every 1 meter interval, there is a box. So if it has collided with 4 boxes, that means it has traveled how many meters? 4 meters. 1, 2, 3, something like that. 1 meter, 1 meter. All right. So now I have taken, after n number of collisions, what will be the mass of this, people? After n number of collisions, what will be the mass of this? Mass of this will be, hurry up. After n number of collisions, what will be the mass? 6, 7, 8, 9. Likewise, it will be 5 plus n. Yes, 5 plus n. 5 plus n kilogram. Hope you understood that. If there are 2 collisions, the total mass will be 7 kilogram. Why? How? 5 plus 2. If there are 5 collisions, total mass will be 10 kilogram. How? 6, 7, 8, 9, 10. Likewise, it will be combining, no? Right. So now the new speed, will assume that it is 3 meters per second. And let's see how many times it should have collided. For that, you can use final linear momentum in this direction equal to initial linear momentum in that direction. Final linear momentum, I'll take it as 3 for the time being. It is 5 plus n into 3 equal to initial linear momentum. Its initial velocity, I have marked it. How much is that? It is 10 meters per second. It's given in the question, 10 meters per second. Therefore, if I put that 10 meters per second, right? What is it? 5 into 10. 50. So 5 plus n is equal to 50 by 3. 50 by 3 is 16.66. No, because 16.66. Then n is equal to 11.66. 11.66. So if it has collided 11 times, it is still not less than 3, no? So it should collide how many times? So box should collide how many times? Box should collide 12 times for its velocity to be less than 3. Because the answer, no, not 12 times, 17 times, 17 times, sorry, not 12, 16.6, no, correct, sorry, 11.66, so 12 times. Why? If it collides 11 times, the velocity will be slightly higher than 3. And the 12th collision, it will become less than 3. This is 11.66 now. So it's between 11 and 12. You can't have 11.66 collision. So before this, the collision before this is the 11th collision. During 11th collision, the velocity will be slightly greater than 3. And at 12th collision, it will go below 3. Therefore, the answer for this question is, people, third, 12th. And this is how we have to do it. We have to assume that the objects are combining. If not, we can't do this question. If not this question, it's impossible to do this. And the next one, 32. 32. Person having long-sightedness observes a book at a distance of 25 centimeters from the eye. He could not observe the book clearly. So this person is short-sighted. What's the problem, people? If the person is short-sighted, and if the person is not wearing spectacles, this is what's going to happen, no, people? In O level also you have learned. No, he's long-sighted. Sorry, he's long-sighted. This will happen. Light rays will get focused behind the retina, like this. Somewhat behind the retina, like this. This is what's happening. If he or she doesn't wear the specs. All right, fine. Now, what is the question? At this time, the focal point of eye lens is A. Right. This is the focal point. Eye lens. Now, what should I do? What lens should we want to rectify this, people? What lens should we want to rectify this? Hurry up.
Convex.
Yeah, convex lens. So when you wear a convex lens, what happens? When you wear a convex lens, you need to wear a convex lens along with this so that you can make the ray converge in front of its initial position. So when you wear the convex lens, this is going to happen. Same object distance, but image will get focused. Right, now tell me what will happen to the new focal point of the lens combination, people. What will happen? What should happen? Wait, if he observes clearly by wearing suitable lens, what is the type of that lens and the focal point of the combination lens? Now, when you have just one lens, this is the focal point. When you put two convex lens together, what will happen to the focal point? Will it increase or decrease? Will it increase or decrease? Will it increase or decrease? It will definitely decrease when you put two convex lens together like this, because both will converge the ray now. Both will converge the ray. It will get converged even closer. Therefore, the answer to this question is B. Simple. But careful, what lens should be worn? Convex. So since concave, this is wrong. Concave, this is wrong. Okay, and the answer is B. The sole reason is when you put two lenses together, two convex lenses together, then the focal length will reduce. Earlier, the focal length is given as F. When I put another lens to rectify this problem, the focal length is going to move forward. This is the explanation for you. With one lens, it will be at A, and with two lenses together, it will be at B. The answer is first. Right, that's enough. We will not make it too complicated. Don't make it too complicated. Don't try to write equations and all. Just look at it simply. Without the lens, this is how the ray will get converged. With the lens, this is how the ray will get converged. Moving on. Next one, 33. Question number 33. In the shown potentiometer circuit, shouldn't it converge to the retina? Where? Which one? Second diagram. Second diagram, yeah, it will converge to the retina. Yeah. What is the question number? No, when it converges to the retina, the image distance is only that. So when this happens, this is our image distance. This is image distance. This is object distance. And we are getting a real image. Therefore, focal point should be somewhere here. This is not the focal point. Careful. That is the point where the image is formed. Okay, next question. This one. In the shown potentiometer circuit, the internal resistance of the cell is invisibly small. The resistance of the potentiometer wire is R. Right. It's R. Okay. The balance length obtained for balancing the cell E naught in the potentiometer wire is L. What is the change that should be done on the potentiometer in order to change the balance length to 2L? Right. Now, let me draw this quickly. What should we do, people? Now, let's start. E naught is the potential difference. Now, the reading here is going to be 0. When you take a balance length, the reading here is going to be 0. Therefore, the potential difference across this part is E naught. E naught. And this is the potentiometer wire. It has a resistance of R. They have told in the question. R. Resistance is R. Potentiometer wire's resistance. Okay. Now, there will be a current flowing through the potentiometer wire like this. If you want to increase the balance length, what should you do? If you want to increase the balance length, what should we do? To increase the balance length, now this is the equation for now potential difference across potentiometer wire. If you take it as V equal to KL. And what is the meaning of this K, people? K is called the potential drop, potential gradient. Or in other words, you can say potential drop per unit length. Potential drop per unit length. So initially, this is what's happening. Initially, sorry, wait. Initially, listen to me carefully. Yeah? E naught is equal to K1L. I'll take it that way. K1L. Later, same battery E naught, but now we need 2L. The length is supposed to be 2L, means we need to change K. From K1, it should have gone to K2. Correct? Same battery. Earlier we got the balancing length as L. Now the new balancing length is 2L. That means we need to change this K. K is the potential gradient. Therefore, if you equate the equations 1 and 2, 1 is equal to 2. Therefore, you can say K1L is equal to 2K2L. L can be cancelled out. Therefore, what is happening? K2 is equal to K1 by 2. In other words, since the battery was not changed, the potential is same. If you want to double the length, you have to reduce the potential drop by half, potential gradient by half. Then only length will be double, because when the multiplication of this is constant E naught. Now we have to see what we can do to reduce the potential of this. Now let me write another equation for potentiometer wire. Okay, for potentiometer wire, you can write this equation now. V equals KL and also V equals IR. Two equations. And for R, what can I do, people? But we know R is equal to rho L over A. Rho L over A. Therefore, you can write V equal I rho L over A. And if I can write it like this, I rho over A into L. This is equation 1. This is equation 2. Now, when you compare equation 1 and equation 2, you will be able to get an equation for K. What is it? Compare 1 and 2 and tell me what is the equation for K? V and L are same. V equal to KL. V equal to I rho A over L. Therefore, K is equal to I rho over A. Correct? I rho over A. That is K. If you can remember this equation, it will be really helpful for you when you do potentiometer questions. I is the current flowing through the potentiometer wire. Rho is the density. A is the cross-section area. These things are constants. No problem. Okay, people. Now tell me, what is our purpose? Now we know K is equal to I rho over A to double the balance length. What should I do? To double the balance length, K must be reduced by half. K must be reduced by half. If you want to reduce K by half, who should be reduced by half in this equation? In this equation, you can say K is proportional to the current going through it. No, people, current going through it. Rho and A are constants now. Rho is the density of this. Not density, sorry. Rho is the resistivity. Resistivity, not density, resistivity. A is the cross-section area. Therefore, I. So listen to me carefully. If you want to double the balance length here, L, if you want to make L 2L, you need to make K half K. So if you want to reduce K by half, then who should be reduced? So current must be reduced by half. Current must be reduced by half. Tell me a method to reduce the current by half. Tell me 2 methods to reduce the current by half, people. There are 2 methods to reduce the current by half. What are the 2 methods? In the primary circuit, you can reduce the current by half. 2 methods. What can I do? Using a battery of EMF E by 2 instead of E. Can we do that? Instead of E. No. You can reduce the electromotive force here. You can reduce by half. Or what is the other thing you can do? Doubling the resistance in the circuit. Doubling the resistance in the circuit. 2 things. You can do both of these things, not only one. How do you double the circuit resistance of the circuit, people? Already the resistance of the potentiometer wire is given as R. Therefore, if I put another resistor in series with value of R, this condition will be satisfied. Therefore, for this question, the answer is second one. Join the resistance R in series with the potentiometer wire. That would be the option. because to fulfill this condition, you need to increase the current. If you increase the current through the potentiometer wire, K will increase. If you reduce the current through the potentiometer wire, K will reduce, so the balance length will increase. Therefore, there are two options you have. One is, now fourth is wrong. Instead of cell E, use another cell having EMF twice that of E. No, should be half of E. Half of E, not twice that of E. That's why I gave you both the options. Instead of cell E, use another cell with internal resistance and having EMF half that of cell E. That is also wrong. It can't have internal resistance and half this. No. If it's E by 2 and if it has internal resistance, the voltage it gives out will be less than E by 2. That's why the fifth is wrong. Therefore, the best option would be second. All right, potentiometer questions, they are a bit, sometimes they can be a little confusing and complex, but if you think of this, it's not that hard. Just revise this. Okay, fine. How many of you got this answer? Second one. Is anyone who got the second answer? Good. Right. Okay. I'll take one more minute. And explain that to you with quick numbers. I'll explain that to you with quick numbers. Now imagine a situation like this. Just let me quickly, I'll just quickly draw the diagram. I have a battery, no internal resistance. E is equal to, let's say, 10 volt, no internal resistance. And I have the potentiometer wire. And I have this E naught. Sorry, and let's say I have this E naught. Right now, think carefully and tell me, if now 10 volt, this is 10 volt. If E naught is equal to 4 volt, what is this now? What is this length? Now, let's say the potentiometer wire has a length of total length of 100 centimeters. Tell me what is this length now? Tell me what is this length? 10 volt is the voltage of the primary cell. This battery is 4 volt. Now what will be the length here? Easy. Total length is 100 centimeter. Right, very good. It will be 40 centimeter. Why? 100 centimeter is for the entire 10 volt potential drop. All the 10 volt will be dropped across the potentiometer wire because there's no other resistor. So for 4 volt, we need just 40 centimeters. Got it? Right, now let's see if you are answering this correctly. What will happen if I put another resistor? Now, let's say the total length of the potentiometer wire is 100 centimeter and the resistance of that is 10 ohm. Right, now I put another 10 ohm resistor in series like this. Okay, this is 10 ohm. The potentiometer is also 10 ohm. So don't forget that. And it has a total length of 100 centimeter. Now E is 10 volt and E naught is still 4 volt. We did not change that. Now tell me what will be the balance length, people. Can you tell me the balance length now? For that, we need to know the new potential drop. What will be the potential drop across the entire, potentiometer now? Can you guess? What is it going to be? It's going to be 5. Very good. It's going to be 5 volt because this 10 volt will be, half of it will be given to the potentiometer wire, half of it will be given to 10 ohm. All right. Now tell me, guys, what will be the new balance length? What will be the new balance length? It will be 80 centimeter. Exactly. 80 centimeter. How is it 80 centimeter? Now 100 centimeter length is for 5 volt. So for 4 volt, it will be 80% of that length, that is 80 centimeter. Earlier, 100 centimeter was for 10 volt. So for 4 volt, it's 40 centimeter. Now, this 10 volt is given to this and this. So this is how you double it. Understood? This is that numerical explanation to justify this is the correct answer. Right. I think that's enough. We'll move on to the next part. Okay. Right. an escalator can lift passengers upwards up to a vertical height of 30 meter within 30 seconds. Sorry, 10 meter within 30 seconds. Vertical height of 10 meter within 30 seconds. A childish person of mass 50 kilogram. I think what they're supposed to be is a mischievous person. That's what they're supposed to say. 50 kilogram walks downwards in an escalator which is moving up. Right? Because of that, he seemed to be at rest with respect to the building. Now, you might have noticed it. Escalator is supposed to take him up, but if you walk against it, you will not go anywhere. You will be at the same point. You will be at the same point. No? And if he did this for 30 seconds, what is the total work done by him on the escalator respect to the building? Right. Now, if he doesn't move, what would have happened? Tell me. This is the escalator. I'll just take the escalator like this. There must be steps and all, but never mind. In 30 seconds, he should have this should have happened. He would have been here when time is equal to 0. Now he would be here after 30 seconds if he did not do anything. And what is the vertical height he's going to reach? 10 meters. Okay, so increase in energy. What is increase in energy, people? Increase in energy equal to mgh. That is equal to his weight, his mass. 50 into 10 into height. 10. Answer is 5,000 joules. That is the energy. When he moves, what is happening, people? When he moves, he is supposed to be here after 30 seconds. We are at the top. After 30 seconds, he's supposed to be here. But he is here. He's not moving with respect to the building. He's not going up. Why? The escalator is performing the same work in 30 seconds, but he is performing equal amount of work against the escalator. Do you understand? If he had not done anything, if he had just minded his own business and if he had stood still, escalator would have taken him up. So that will increase his potential energy. How much? By 5,000 joules. Here, even after 30 seconds, still he is there, means he was supposed to be there. What has he done? Escalator is trying to increase his energy, but he is doing exact opposite work and he is maintaining his energy at the same level. Therefore, how much work should he done? How much work should be done? This much. This much work should be done. So to put this into words, within 30 seconds, escalator does a work of 5,000 joule on the man. So for the man to remain at the same point, what should he do? He should perform same amount of work against the motion of accelerator. Against the motion of escalator. Why am I saying accelerator? Vertical accelerator. Okay. Second one is the answer. Minus sign is because he has to perform work against. That's why the minus sign. There is a minus answer and a plus answer. That means definitely the most appropriate one is going to be the minus one. Okay. Right. Anyone who got this answer? Right. Question number 36. As shown in the figure, block P, Q, R of identical masses are kept on the light and frictionless pistons, and the system is maintained at equilibrium. The amount of fluid is drawn according to the scale. Right. Initially, the value at points valves at points A and B are kept closed. So initially they are closed. Now, they are asking what's going to happen when you open the valve. For that, we need to know the pressures. What's the pressure here? What's the pressure here? And what is the pressure here? Tell me, how do you do that? Identical masses. Blocks PQR have identical masses. Therefore, I can say they all have same mass. That means M, 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 M. And look at the cross-sectional areas, people. This is A1, A2, or else I can put AP, AQ, and AR. And because of that mass, because of that weight, there's going to be a pressure created here. There's going to be a pressure created here. I'll take it as P1, P2, P3. P1, P2, P3. No. We'll take it as a PP, PQ, and PR. And ultimately, you will get a pressure here P1, or else P1, yeah, P2, and P3. And all those points, according to the diagram, they are all at the same height. No, they are all at the same height. Now, we have to compare between P1, P2, and P3. If P1 is larger than P2, water will go from P1 to P2. If P2 is larger than P3, water will go from P2 to P3. Therefore, when water goes, this level will go up, this level will go down, something like that. That is how you have to approach this question, people. Right, now tell me, which pressure is large here? PP, PQ, PR. Oh, first of all, let me write the equations. P1 is equal to PP plus H rho G. P2 is equal to PQ plus H rho G. And P3 is equal to PR plus H rho G. Okay. And PP is going to be equal to mg over AP. PQ is going to be equal to mg over AQ. And PR is going to be equal to mg over AR. Which pressure is larger here among these pressures? Definitely PP is the larger value because smaller area. So larger pressure, same weight. If PP is the larger value, H rho G is common in everything. Among these three, who is the larger value? P1, P2, P3. Okay. What is the answer? What is the answer? Tell me. Among the two valves, when any one of them is open, there is no change in the heights of the block. Wrong. That is wrong. Because water is going to flow due to pressure differences. Water is going to flow due to pressure differences. Among the two valves, when only A is opened, block P will rise while block Q moves down. Wrong. Now, what will write the final answers then? When A is open, what will happen? When A is open, when only A is open, sorry, when only A is open, what will happen? Water flows from, let's say, P to Q. So, P falls, Q rises. That's the first point. Second point, when only B is open, what will happen? When only B is open, water flows from where to where? Q to R. So Q falls, R rises. That way you have to compare and get the answer. Which one? The fifth one. Among the two valves, when only B is open, block R will rise and block, yeah, fifth is the correct answer. Fifth one. Follow me. Can I see a raise of hands if you understood this explanation, please? Right. It's not very hard. It's just a comparison of pressures. And then depending on the higher pressure and lower pressure, you can decide to which side will water flow. Right, good. Moving on. Next one, 36 done, then 37. 37. Okay. A lens of focal length f1 kept at A. When both valves are open, only R will move up. Oh, okay, sorry, I forgot to explain that. Right. But what will happen when both valves are open, people? We'll discuss that also. Sometimes it might be useful for us. When both valves are open, what will happen? No, we know we have decided one thing, that is sorry, something happened. You take the pressures P1, P2, P3. We know P1 is greater than P2, greater than P3. So when both valves are open, when both A and B are open, what will happen? Open from P1, what is going to go to P2? From P2, what is going to go for P3? So both P will fall, Q and R will rise, but who will rise more? But R will rise more. Because here we have low pressure. So we need to balance the pressures, and until pressures are equal, they have to move. So that's going to happen. Water will flow from P1 to P3. So therefore, P will definitely go down. Q will slightly go up. R will go even more. That's the final verdict. Okay, fine. And then let's move on to the next question. A lens of focal length f1 is kept at A, having xy as its principal axis, forms an image at point B with magnification m1 for an object O1. Right. Let's use different colors for this object O1. No, wait. Right, I'll draw it here. Quickly, I'll draw it here. Sorry. Two diagrams. Okay, so initially the object is at O1 and you have a lens here, and then you are getting image at B, image 1. And then you are keeping another lens. This is f1, this is f2, I think, f2. Now the object is kept closer to the lens. And again, the image is obtained at the same position, I2, O2. Right, let's read it. Okay. Likewise, another lens of focal length f2 kept at A, having xy as its principal axis, forms an image at point B with magnification m2 for an object at O2. Which one the following is true? For both, what is common, people? For both, what is common? Image distance is common, no? V, same V. But they are going to have different object distances. U1, here, U2. Both lenses used are convex. Yes, because only convex lenses can form what do you call that? Can form images on the other side of the lens. So definitely A is correct. If A is correct, this is wrong, other three are possible. C, we can directly decide now, people. C. Why do I say that? Because now they have given you the angular magnifications, linear magnifications here, M1 and M2. What is the equation for M1? M1 is equal to V over U1. M2 is equal to V over U2. And when you compare these two, who is larger? U1 is larger than U2. Therefore, M1 is going to be smaller than M2. C is also correct. Did everyone understand that? Simple, no? C is correct. That means fourth is wrong. Oh, yes. That means fifth is the answer. Fifth is the answer. And how do you decide about B? Quickly, we'll do it. You are getting the image here. This is the image. I'll take this as V. I'll take the lens focal length as F and a random object distance U. So if you to explain part B, you can apply lens formula for this one. 1 over V minus 1 over U equal to 1 over F. 1 over V, you see the image is obtained on the right side. So let's put a negative sign for that. minus 1 over u equal to 1 over minus f because it's a convex lens. You can multiply everything by minus 1. You will get 1 over v plus 1 over u equal to 1 over f. Now, f is what we are supposed to find out. 1 over v is constant. 1 over v is constant. So, if u is large, f will be large. U is large, f will be large. Right? So, we know u1 is greater than u2. That means f1 will be greater than f2. That's why B is correct. Okay. This should not have been hard. It's just you draw the two diagrams and do the comparison. 37 for you. At 38, how many of you tried this question? Put your hands up. This by far is one of the challenging questions, but you can do it, no? Right? I can see a lot of people have done it, but I'll quickly explain it. Right, it's a good question. A constant force F acting on a frictionless piston of area of cross section A. Density of water is rho, and viscous force can be neglected. If viscous force can be neglected, you can apply Bernoulli's theorem. What is the time taken to expel water completely through the whole of the area of cross section simple A? Right. We need to get all the water out. For that, we need to plan that. What is the plan to find the final time? Yeah. So how do you find the time? Find the time. I need to do this. First of all, I will consider a particle like this moving along a streamline like this. That's important, people. So the particle is coming out here, right? At speed v2, and here its speed is v1, and here it has a pressure of P1. Here the pressure is P1, and here the pressure is P2, which is equal to pi. And P1, remember, P1 is equal to F over A plus pi. If I'm applying a force of F again on this area, and here also we have atmospheric pressure pi. So P1 is going to be equal to F over A plus pi. Don't forget that, P1. Now here, at this point, we can find the volume flow rate. Here, volume flow rate, we can find out how much is that. Volume flow rate is equal to that is total volume divided by time taken. So volume flow rate at this point is, people, AV2 equal to, what is the total volume? Total volume is AL. Do you agree with me? Total volume of the syringe. This part is a small part, so I think we can ignore they have not given this length, people, so we can ignore that. A into L is the total volume, so that entire volume should be taken out at a given time. That time is only T. So if you want to find T, all I need is AL divided by simple A V2. So yeah, I don't know. V2 is going to play the major role here, because capital A, capital L, simple A, all can be there in the answer. We need to find out V2. We need to find out V2 because this is where the liquid is coming out. So for this point, I have found the volume flow rate, and then I'm applying this. So can I see a raise of hands? Can you understand this? If you have any problems, please ask. This is how you have to start the question. This is where the liquid is coming out. So the volume flow rate at this point will be equal to total volume divided by the total time taken for entire liquid to be taken out. Okay, let's find out V2 now. How do you find out V2? We can first of all start with continuity theorem. How? Continuity theorem is A1 V1 equal A2 V2. So AV1 equals simple A V2. Therefore, I don't need V1 in my answer. Final answer is V2, na people? V1 is equal to AV2 over capital A. Simple AV2 over capital A. Right. I'll take this point as X, and I'll take this point as Y. For points X and Y, Bernoulli's theorem. Bernoulli's theorem. Right, how do you do that? Pressure at x plus half rho Vx squared equal to pressure at y plus half rho Vy squared. H rho g we don't have to consider because both the points are the same horizontal level. What is pressure at x? That is P1, and that is equal to F over A plus pi. Don't forget pi. Outside atmospheric pressure is there. Along with that, we are pushing. Plus half rho Vx squared, that is half rho V1 squared, equal to pressure at y. It is exposed to air now. Therefore, it's pi plus half rho V2 squared. Pi, we can get rid of that. Gone. F and A are there in the answer. We'll leave it as it is. Now let's find the rest. I don't want V1 squared in my answer. Therefore, F over A plus rho by 2 into what is V1 squared? This whole thing squared. Simple A squared, V2 squared over capital A squared equal to on the left side, sorry, on the right side, rho by 2, V2 squared. Guys, I need V2. So let's make that the subject. I will leave F over A on the left side, rho by 2 V2 squared minus simple A squared over capital A squared into rho by 2 into V2 squared, this one. And I think we can take V2 squared common, no, because V2 squared common, we not only V2 squared rho by 2 common into 1 minus A squared, simple A squared over capital A squared. I think they have taken LCM. That's why you see A squared, simple A squared is there in the answers. So let's do that. F over A equals V2 squared rho by 2 into capital A squared minus simple A squared divided by capital A squared. And finally, I will be getting this. V2 squared is equal to 2F, 2 goes up, 2F A squared, sorry, 2F A squared over. No. Wait, it should be A because you can cancel out one of the A's here. So forgot here. Cancel it out. 2FA goes up. And at the bottom, what will you be getting? Rho into this whole thing. A squared minus simple A squared. Finally, V2 is square root of 2FA over rho A squared, capital A squared minus simple A squared. Then you have to substitute that here for time. Time will be equal to AL over simple A into V2. This is this. 2FA over rho A squared minus simple A squared. What is the answer, people? What is the answer? I can take this, right? I will write like this now. Time is equal, after that continue. A and L, you can keep them aside. L over A. How many answers have L over A? Right, there are 4 answers with L over A, gosh. And this square root, we can write it like this, see if you can understand. Huh? This part will go up, rho A squared minus capital A squared minus simple A squared over 2FA, and this A, I will borrow it, I will, what do you call that? Take it inside the square root. That means it becomes A squared. No? If I take that A inside my square root, it will become A squared. So that A squared and this A will cancel out. And finally, you will get an answer like this. T is equal to L over A square root of A rho A squared minus simple A squared, and at the bottom you will have 2F. I think the fourth one is the answer. Anyone who got the fourth one? Nice. 38. Fourth one. It's a very different question, a very different approach. We very rarely come across this time. It's either velocity or pressure. That's what we find normally when it comes to Bernoulli's theorem. So if you are wondering how to connect time, this is the only way we can connect time. Okay, right. So if you could not get the answer, have a think about it. Try it again. It is time consuming. So I don't recommend you to do it right away. If you can do it quickly, you can of course finish it quickly, but if you feel like time is going to be consumed a lot, you can leave it and try the others and come back to this. But yeah, when I did it first time, I did it very quickly. I didn't take this much. I'm taking this much long because I'm writing all these things and explaining you one by one. But if you do it, I think you can get it. But anyways, idea is important. Don't buy hard the answers or anything. Approach, ideas, small things. 39th question. Two blocks of each mass m are kept one over the other. The flow is frictionless. The coefficient of static and dynamic frictions are mu s, mu k, respectively. Initially, both blocks are kept at rest. Which graph correctly shows the variation of acceleration with force when a constant horizontal force is applied on the block, which is at the bottom? Right. Look at the graphs. All the graphs are straight lines, and some other things are happening there. Right. And most of the times you have this small hiccup whenever they have given this part. So you can anticipate a graph with a small sudden increment or decrease. Therefore, probably first can't be the answer. If they have mentioned that the kinetic coefficient of kinetic friction is less, that means there's a high possibility, and the object is starting from rest as well. There's a possibility of sudden increment or decreasing, right? So if we can rule out the first one, obviously. Now, what will happen here, people? For smaller values of f, for smaller values of capital F, upper box will remain at rest on the bottom box. Can you understand? Bottom box. What's the reason? Because limiting condition is not yet reached. Limiting condition is not reached. So for smaller values, this is how the system is going to look like. The two blocks, they both have the same mass, I think, right? Are they? Yeah, they both have the same mass. They both have the same mass. Therefore, I'll put M and M. I'm applying a force here. This will try to stop this one. So there will be a frictional force acting in the opposite direction. Simple F. And here there will be another friction acting. Simple F. And what is this frictional force? Tell me, is it kinetic or static? This friction. Kinetic or static? Arya? This friction, is it kinetic or static, people? It will be static. The reason is the block on top is not moving with respect to this. It both will move together. That's what happens when f is small. Both will move together. Both will move together. Okay, both will move together. Then tell me now, what is the equation? Now there will be an acceleration here. There will be an acceleration, simple A. So what is the equation I should be using here, people? Equation is whose acceleration is which graph correctly shows the variation of acceleration A? Whose acceleration is that then? The systems. Okay, fine. Now here, what is the equation for acceleration? We can say we can apply F equals ma. So F is capital F for the system. We can apply it for the system because the entire system will be moving with an acceleration. Both the blocks will be moving together. When F we give is small, you can write at home. You keep two boxes like this. You keep a small force and pull the bottom box. Both of them will move together. But if you pull the bottom one with a larger force, bottom one will come to the right. Upper one will just stop. It can't move anymore. It can't move with the bottom one anymore. So that is F minus F equal to MA1. I'll put MA1. Oh, no, MA, right. Now we need to plot a graph for A, no, people. No, what should I put for M? 2M, no? 2M. 2m. So A is going to be equal to F minus F over 2m. That is the equation for acceleration. Therefore, when F is increased, graph is for capital F versus simple A. So when you increase capital F, then your acceleration is also going to definitely increase. So we'll have to go with an increasing graph. Now, when limiting condition is attained, what will happen? Now this will happen. You are giving a force which is larger than the limiting frictional force. Now I'm giving F, which is a value larger than the limiting frictional force. Then what's going to happen? Then this can't stop F from moving away from it. Therefore, F between these two, there will be a, what do you call that? There will be a relative motion between these two. There will be relative motion. So F will move forward now without this. F will move forward without this. There will be a frictional force acting. What friction will be acting now? What friction will be acting on that people? Fk. On this, there will be an Fk on the other side. But now, capital F will be the bottom box will be moving independently. Both boxes will not move together. This will move separately. Bottom box moves separately. Now for the bottom box, if you apply the equation, bottom box, you can apply it separately. F equals ma. F is the force we are applying minus Fk equal to ma. So now A is equal to capital F minus Fk over simple M. Now what's the difference between these two graphs, people? Tell me what's the difference between these two graphs? I mean, if you take this graph, A is equal to 1 over 2m into capital F minus F over 2m. Do you understand this for the meaning of this part? I hope you can understand this. Here it is this A equal 1 over simple m into F minus Fk over m. Therefore, what can you say about the gradients? Which gradient is high? This is a low gradient. Here, higher gradient. Therefore, which one graph is the most suitable one? And the other thing, acceleration, will it increase or decrease? Acceleration, will it increase or decrease, people? We know F is greater than Fk. Fk is smaller than F. Static friction is larger than kinetic friction. Therefore, this value is which acceleration will suddenly increase because we are subtracting F. We are subtracting F. If you subtract a smaller value, A will increase. Now, my point is this. F A equals F minus simple F over 2m now. When F decreases, A will increase. That's why this sudden increment will be there. And gradient is larger afterwards. Therefore, the best answer is second. Initially, the gradient depends on 1 over 2m. After it starts moving independent of this, gradient is 1 over m. Therefore, it will be steeper and acceleration will increase because friction is reducing. Friction reducing means resultant force is more towards right. It's like 10 minus 8 in the first initial case. Here it's like 10 minus 6. So 10 minus 8 is just 2 Newton of resultant force. Here 10 minus 6 means 4 Newton of resultant force. Therefore, here high acceleration, here lower acceleration. That's why the graph goes up, doesn't fall down. Answer is second. Right. That is a 39 question for you. Then 40th one, right? Fine. Yeah, the easy questions to do. Okay, guys, that's enough for today. 39. We have done 39. Oh, no, yeah, 39. So we have 11 more questions.